40 seconds, the reaction has slowly started, and it is a structural permanent solution. If you see now, the water has stopped going inside and the water is raising. If you see from the bottom, the stream of water is getting reduced. It has expanded, not very much, but to the reasonable extent so that it is spread all around. The water from top is flowing out. The water which is coming out with gushes, it is now slowly stopping. And within a matter of 1 minute, the total process is over. This can be similarly used in our basements. We are having a lot of problems in our basement. The water comes inside and you cannot stop it by foam. If you stop it by foam, tomorrow, once the foam is thrown out, the foam is not durable. These materials are tested for durability of 100 years. There are long-term tests been done in field of about 20 years, and then by extrapolating, these materials are very suitable and remain almost permanently, which is very, very important. Foam is not stable. Foam does not have a capacity to bond to your concrete. Foam does not have the water pressure bearing capacity. So these different polyurethanes are very, very handy when you try to stop water during construction. For example, this is the type of the water. You can try to put any foam inside, which is expands 50 times or 40 times. It cannot stop the water. Because to stop this type of water coming under such a pressure of 6 bars or 10 bars, you really need polyurethanes which are structural, which can harden totally underwater within a period of 1 to 2 minutes. So totally your construction can go unabated, as well as it forms a permanent seal. It's a permanent solution. If you see the water is going on reducing in a matter of just minutes. So this is the real live stopping of water. So within about 1 or 2 minutes, the flow of water is reduced. And these are the only means of providing permanent solution during construction as well as after construction. Still more versatile resins are the two components silicate resins. There are also polyurethane is not the end of the story. There are silicate resins. This is organo-mineral silicate resins. Silicate resins, there are also foaming silicate resins and non-foaming silicate resins. Silicate resins bond very well under wet conditions. Silicate resins, they also foam structurally. Say 1:3, they can be used for the lifting of the structures. So they can go very nicely inside the soil and do the stabilization. They are structural. They can be also used for example, for the same purpose that we use the polyurethane injections. If there is a very fractured rock, we can once again, and there is no water, there can be a fractured rock with water where you need polyurethanes, because polyurethanes form only in presence of water. Whereas as far as silicates are concerned, silicates form on their own and they can glue this fractured rock, especially during constructions. You see here, this is now already injected. This foam with restrained expansion also develops sufficient structural strength. So when the machine passes through, it offers enough resistance. You can see the very fast foaming. Even if there are some remnants of water, it will throw away. These are also available. These are mostly used on BIM machines, and this would be a good example to show a tunnel boring machine. When the tunnel boring machine is moving around, geotechnical surveys have already identified that X meters you are having. So you are already putting in the silicate foam. It cannot move, the shield cannot move. So the silicate foam is injected. This foam is not injecting 50 or 60 times. Within 45 seconds, this has got, they have maintained the foaming factor to 8 to 12. See, one thing you have to remember, you'll see some certificates which will tell you my foaming is 1 is to 15 and my compressive strength is 15 Newton. This is not possible. Because on one foaming factors they give as a foaming factor, the tests are done with only 1 is to 1 or 1 is to 3 foaming factors. So you can't have both the things. As the foaming increases, as the foaming increases, the compressive strength decreases. Now these foams are also excellent for soil nailing. You have inside, you have the soil nailing, say about 15 or 20 meters. You got self-drilling anchors. It's a very, very versatile material. It doesn't expand. In this particular case, it is non-expanding. It will slightly expand so that it creates a bond. If there is a water inside the structure, you cannot use the epoxies for fixing your anchors bar. Whether it is self-drilling anchors for soil stabilization or it is even transfer of loads in your RCC repairs to be done to foundation below the water, there you have to go in for silicate technology. So you shall be seeing now how many materials and how many parameters a engineer, a geotechnical engineer has to consider before just writing specifications, which I see in many dam specifications. He said repairs are to be done by 2-component polyurethanes. This does not say anything. The performance criteria should be given. What strength you require for repairs, what viscosity is required, in how much time, for example, this develops a pull-out load up to 20 tons within about 10 seconds, within about 10 minutes. Within about 10 minutes, your reaction is over. It is developing the full strength. And these are the resins that you have to consider as new generation resins, and a still more versatile development or still more versatile material are the acrylic gels. These acrylic gels, they are fantastic as far as the sealing is concerned. They have got adjustable pot life. You can adjust the pot life from 9 to 10 seconds up to 30 minutes, depending on the flow of water, depending upon the penetrability. They have got a very, very low, the lowest viscosity. They can penetrate to the finest possible pores. As good as it is, as good as water. Wherever water can reach, they can reach to. They're more important, which I will come on my last slide, which is very, very important. They should be approved for use in groundwater. There have been major accidents, which I will show you. You can go on the net and find it out. Under the name of gels, some wrong poisonous materials are still being used. You have to be very, very careful. They should have a groundwater clearance certifications, especially coming from European countries. There is a CE marking, there is a groundwater certification. You should ask for certificates, and there are durability certifications. There is a durability certifications for gels, also for 120 years. A testing in the field for 20 years. Please note, every gel is not a gel. Some gels, they will just become gels. After some time, they will shrink. Once they shrink, the joint or whatever it is very vulnerable to the water entry. So they react very fast. You can see within, they are having up to, when it reaches say 100, the viscosity of 100 MPAs, it is still pumpable. Then the reaction time, in about say 10 to 12 seconds, you can control it. Then it starts increasing in the gelation time, and it is gelled. Within about 20 minutes, it is a proper gel. I will show you one or two videos to show you the type of the gels. These gels are normal, as well as these gels are also can be fortified with acrylics to give it a characteristics which is so flexible, which you can convert it into a joint filling material. There are so many projects they are coming to us in this type of railway underpasses. The railway underpasses, they are normally made out of precast element having a depth of about 4 meters. They're 4 meters in the length and the depth of about 60 centimeters. They're placed side by side. Sometimes the joints are filled by uh, some boards. Sometimes they are filled with some other materials, but they fail, and the water starts coming inside the roads. The roads become unusable, visible, and the gels are the only solution. Please note my words. I'm saying only solutions, only permanent solutions. Initially, you can put some foam inside to stop the water if it is coming in a very big conditions. But if you see these joints, sometimes there are water stops are provided in the two connecting things. Sometimes we put the styropor inside. Sometimes you pull the cyrodex or dimple boards inside. But by some chances, these are breached. The water still passes. The joints become very vulnerable. There are suggestions from the people saying that you use only foam, no problem. It is stopped. Of course, it will be stopped for 2 months or 4 months or 6 months because uh, foam is not a permanent material. Some people say you put some other polyurethanes inside, rigid polyurethanes or flexible polyurethanes. No, this won't help either because you have to create a joint sealing material. A joint sealing material should have a adequate bonding on the sides. Joint sealing material should have enough elasticity for expansion and contraction, and it should become a seal. Joint sealing and joints, because this is very very important. So any other method won't work. So over a period of time, when you use the gels, you inject. You can see it is such a simple process. It's a single step process. You make the simple one step process into 4-step process or 5-step process, or put some injections inside, put some foams inside. Okay, you can still put some foam inside to stop the water initially, but permanently what is important is a gel which will set inside. This material is also very very important in precast joints. In precast joints of the segments, you have already gaskets put inside. However, due to the constructional problem, these gaskets are not 100% waterproof, and the water starts coming in through gaskets. But please remember, at the end of the day, they are joints. You can inject through the joints by needle injections. Also, you can inject it from two different sides. You don't have to puncture. Sometimes you can directly puncture the gaskets, go behind it if the water stop is less, water not stop. If the water entry is less, if water entry is more, you can do it through the packers, which are put at 45 degrees. They go behind your gaskets and then create the same thing what has been created. The same technique, you are going behind that physical barrier. Some physical barrier is should put. If they have not put a physical barrier, and if your width is 60 centimeter, you can put some cyrodex board up to say 30 centimeters. So automatically you get a physical barrier. Go behind that 30 centimeter at 45 degrees angle. Inject a gel inside it. So a little bit of gel will come because there is not a sealing with the thermocol or cyrodex board or dimple boards. Some material will go there. It is good for you. If you want more in sophisticated, if this comes in the factory floorings, you also have got a small portion kept above. You can feel a joint filler. You can seal that joint by polyurethane joint sealants or polysulfide joint sealants. So many joint sealants or polymer joint sealants, if it is to be used. But this is the basic techniques. There's no other technique, and this cannot be a temporary thing. I wanted to show you, for your interest, the material. What material is going inside? It is not enough a rigid material like polyurethane, which I showed you, goes inside. This is just to show you what is the material that goes as a gel. This is a fortified gel. This is just a tire to show you. You see, this is the material, two components. Simply we are powering to show you the type of the material. It gels within no time. Finished. The material is already started gelling. It has already gelled. It is a gel. It is a 3-component gel: A component, B component, an accelerator, and an fortified polymer. You can see here within seconds, within 10 to 15 seconds. And this is the material that is to go inside the joints. If you tell me you put any other rigid polyurethane inside, you put a flexible polyurethane inside, within 10 minutes, it has developed adequate bonding strength, which is most important. Any material you are using to recreate the joints in the segments, or to recreate the joints for the underpasses, or any other joint from where the water comes, a joint is a joint. It is to be treated like a joint. The bonding should be there on the sides, and it should have enough elasticity. You can see here within 10 minutes. That means any water that is coming, it reacts with water, and it is totally elastic. What is more important? What is more important is this material is tested with proper certifications, with proper certificates for a period of 20 years in the field. There are official test certificates are available for this, because the durability. Once you try to put something in a metro project, and the metro project is designed for 120 years, any material that you put behind should have. And also when these are below, you can see it has been tested for 7 bars. That means if you take a foam, a one component foam, even if the pressure is 2 bars, it will throw the foam out. If you take another 2 component foam, maybe 4 bars, it throws out. These materials are to be essentially tested as per EN 2504 to 7 bars, but they remain live even up to 12 bars. That means 112, 7 bars means 70 meter of the head. And the durability testing, these gels are liable to expand and contract inside when they are inside the mud, or inside that in connection with water. They can be tested. Now this has been tested up to 14 years in field, how much it is expanded, because when there is less water, it shrinks. When there's more water, it expands. If you see the cycles over a period of 14 years, and this can be extrapolated. This can be extrapolated, and engineering estimation of a durability of this gel is 120 years as compared to your PU foam. Or a PU foam doesn't bond to concrete. A PU foam cannot go inside the joint. It can't bond on the sides of the joint. A PU foam cannot be so flexible as what I said. PU foam cannot be living for 120 years. So if you want to do some permanent solution, these are the permanent solutions are available to you. And more than that, what I said, this has been tested. These have been tested for pressure and durability in field up to 12 bars. This I think there's a no-dig show going within simultaneously. There's a micro tunneling. Even if there is a water pressure line which is having a pressure of about 12 bars, and the joints are leaking, because they can be also built, they are micro tunneling, but they're also built in the segmental way. The water can go inside, which is very dangerous. Drinking water can go outside. There's only one way to stop it as of now, using fortified gels. It is not one component polyurethane. It is not two component polyurethane. It is not one component or two component flexible polyurethanes. It is not a two component structural polyurethane, because we need here a flexibility. We need here a good bond. It should remain under pressure, and we also need the durability. So these are the solutions available now on a simple example. If there's a basement, this is a basement which is done in Bombay. This is a 6-level basement. A 6-level basement in BKC, where the water was coming with this strength. And we use the same technique. Since more water was coming in the beginning, we use the polyurethane foam, a one component polyurethane foam or a two component polyurethane foam, to stop more water coming inside. And that is a temporary solution. You need to use a foam. A foam is a temporary solution. A foam is not a permanent solution. We used also some physical means. You put some rods inside. You can put some lead inside. You can put, because the water has to be stopped, because injection has to work. And then we are injecting, of course, with the knowledge of the structure, we are injecting with the knowledge, the expertise, with the trained applicators. This is 6 floors below 16 meters basement in Mumbai. and this can be stopped. The water can be stopped permanently. What is more important is a permanent stoppage of water, not temporary. They have done several trials for several years. So many people have come and injected so many things. A cement was injected, a polyurethane was injected, a rigid polyurethane was injected. So many things was done. But here also, what we have to finally create, we have to create a sort of curtain walling, a curtain behind the basement, a curtain behind the basement, which can be even for the 7 bars or 70 meters. So it forms a membrane. That was our trained applicator standing there with machinery, well trained. This machinery is from Italy, two component machinery. It is beginning for injection. You require an expertise. You require expertise. We offer trainings. This is a beautiful opportunity for the new engineers to go in for their uh, what do you call it, the internships, or become entrepreneurs. During this time, the jobs are less. We are injecting now behind the basement wall. We are not injecting in the concrete, we are injecting behind. So what we are doing, we are creating a positive waterproofing from a negative side. We are standing inside and creating a waterproofing layer outside. So our whole aim, it is not only stopping the cracks in the concrete from where the water is coming, but we are stopping the source of water. We are keeping that source of water away. And as I already discussed, there's a durability. A durability is guaranteed durability. It is not poisonous for any water, and the water is completely stopped and stopped permanently. I request you, please use these technologies. Please use your engineering knowledge. Please use your uh, geotechnical knowledge. Please use your civil engineering knowledge. Please use your common sense, civil engineering common sense, I would say. And the final use of the injections is also to do repairs of the infrastructures. You must be seeing at many places there is sinking of the slabs there is sinking of the slabs. That means the slabs, like runway slabs or the highways, they settle. Now, when they settle, you have to really see that which material can penetrate. So this is a guideline. You can see you are having permeabilities from 100 to 10, from 10 raised to minus 7. So differing on it depends on all different type of soils and are been put on one side. All the materials are put on one side. We can even go almost to the half the clay penetration capacity. Which material is to be used? This is a small handout or a guideline you can run. Which material can be used when water is there? Which material is to be used when there is no water? Which can set in water, which can set without water, which can set in water or outside water. This is for purpose of injection in soil. The reason I'm telling is, when you are doing, these are the strengths developed. If you see a cement suspensions, micro cement, that develops a very less than after 24 hours. The strength developed is not even 10 newtons after 28 days, because you are putting so much of water into the cement suspension. It's only 15. If you use a good concrete, after 2 hours it starts setting. But before that 2 hours, if the water pressure is high, it can be thrown out. But if you use the silicate resins, you can see within 1 hour or within 2 hours, it can develop a strength of up to 50 newtons. It is very important to select the type of material. This is where it is settled. Now, please remember one thing. This is a pure common sense. When something is settled, it settles because the bearing capacity of the soil is not adequate enough to take the surface loads. Now, this is very important. So, when you are trying to lift up the slab, lifting alone is not important, not enough. You have to first consolidate. Once again, this is engineering property. After consolidating, then you lift it and lift it properly. Then the problem will be solved. This happened to us in one of the quotations which we have given for a big project. They said the other person is doing lifting the slabs only at 20% of the cost. Well, lifting the slabs is not a big problem. The moment a lorry or the plane lands on it, since the underground soil is not consolidated, once again it will go down. Lastly, it can be used very effectively in dam structures, embankments, If there are streams going from upstream to downstream or the other way around, this water can be stopped by using by geologically by georadars, knowing where are the streams. The surface can be stabilized by using acrylic gels wherever necessary. And this is most important things. I think this is one thing which you can simply go on the website and you just put Holland Das Tunnel project, and you will find this is the accident which took place in about 1995 to 1997. The name of the company which was manufacturing, they put about 14 tons of gel inside to stop the water from this underground tunnel. Fortunately, there was no loss to human life. This gel was poisonous. This gel is an acrylamide gel. It is poisonous. So please be careful. Everything that gels is not the end of the story. You can see here, farmers near the construction site started complaining about the cattle becoming paralyzed. They killed about 370 animals to stop giving adulterated milk, adulterated by cows themselves by ingesting this. Human lives did not get affected. 330, 29 wells were uh, poisoned. People could not drink that water. And this is very important. So this is not sustainable. So please get your certification. Say only because a product costs 100 rupees less, and if it creates this type of havoc, one has to be very, very careful. This project stopped for about 7 years and was, I think, between 2009 and 2015. It restarted and now it is completed, but it created this havoc. So at the end of the day, what is important is people need a good training facilities, because you have to have trained applicators, which we can provide. People can be trained by foreign uh, trainers, or people from India can be sent to foreign country for short-term training. Certification is very important. We need the help of CIDC to provide the certifications, because our own certifications are not that valid. If government can help us approve this trainings, those certificates will have a lot of validity. So many civil engineers who are new, they can go for internship for these injections. They can become entrepreneurs. They don't have to rely on someone to become, because they can buy one machine, they can get a training, and they can use it. Ultimately, once again, to repeat, this should be sustainable. Sustainability is the most important. Any technology that you bring to the country, please be careful. It is sustainable. It doesn't kill people. And polyurethane injections is not a polyurethane alone. Injection is a wide gamut of. It is an engineering field. You require a technical knowledge. The universities can start courses. The professors can learn more about it. They can have hands-on experience. So I thank once again CIDC, who is making attempts to revive the economy, and this type of materials will be needed, because now we are going for more and more underground constructions like metros, hydroelectric projects. And please note, by use of engineering knowledge, by use of engineering materials, the problems can be solved, and the constructions as well as the completed constructions can live peacefully for more longer time. Sustainability and durability is the key. Thank you very much. Thanks for patient listening.
Greetings. I am Prasad from Bowling Divisions of Pidilite Industries Limited, and my co-presenter is Jose Ballester Ortiz, who is from Grupo Spain and also goes by a smaller short name, which is easy to remember, Pepe. So from now onwards, we're just going to call him Pepe. We are going to be talking about EIFS, an energy efficient architectural facade solution. And at the outset, let me say that we are extremely grateful and appreciate the opportunity given to us to present this topic to the august audience of industry stalwarts and experts and industry participants. Thank you. Just to start with a brief background of Pidilite Group Puma Manufacturing Limited, it's a JV between Pidilite Industries Limited and Grupo Puma Spain, uh, which is going to start or in a limited way has started this operation in India already. And we are coming up with manufacturing facilities and state of the art R&D facilities, support systems, foreign expertise to support the business in the segment of technical motors in India. To give a bit of background of Pidilite, Pidilite has been manufacturers of high quality products and is catering has been catering for many years to for to a small applicator who might be doing a very small plastering job with 10 or 15 bags of cement to very very high end and complex projects like tunneling and metros and multi-story large developments. Uh, Also, we have state-of-the-art R&D facilities, in-house execution capabilities, which rests with our partners and with our JVs, Nina Patsep, CP, and we have the capability to service across all states. I believe that now we have even capability to service villages which are around having around 5,000 odd population, and also internationally we are having a sizable presence in Middle East and South Africa. Talking about our partners, Group Puma Spain, they are a market leader in Spain in the field of technical motors, and they have very high-end expertise in restoration of old architectural monuments, and they have more than 20 manufacturing facilities in Spain. They have a presence in many European countries, have manufacturing facilities in Algeria, Morocco, Costa Rica, Portugal, and France. Also, they are trying to make headways and are reasonably successful in Middle East, Latin America, and South Africa. I am going to be the agenda, or I am going to be talking about a bit about energy consumption patterns in India, energy efficiency initiatives, ECBC 2017 guidelines, and Pidilite solutions for ECBC compliance for both roof and walls. And the main agenda for today is a detailed presentation on EIFS, which will be done by Pepe. Energy consumption in India. Present energy consumption in India is 12 gigawatt hour per annum, which is expected to rise to 13.5 gigawatt hour by 2030, which roughly is about 12% more. Almost 65% of the energy generated in India is by thermal power plants, with obvious high production cost and more environmental damage by CO2 emissions. Major contributors for energy consumptions are industries at 42%, buildings 33%, agriculture 17%, and others 8%. Building sector contribution is 33% to the total and is expected to rise at 4% CAGR and reach 55% of total contribution by 2045. Industries 42%, buildings 33%, agriculture 17%, others 8%. In the commercial building segment, the large consumption is in the area of HVAC, which is 55%, lighting, which is 25%, internal load 15%, and others is 5%. Uh, Energy efficiency initiatives taken by government and private sector. Uh, as all of us know, the present government especially is focused on energy savings and on environment, and has made pronouncement and commitments nationally as well as internationally, and has taken a leadership positions for CO2 emission reductions internationally. India has committed to reduce the emission intensity of the economy by 33% by 2030 from 2005 level. There are multiple initiatives, but what we just going to briefly talk about is ECBC. So, for energy use optimization, Energy Conservation Building Code (ECBC) had been framed in 2007 and revised in 2017 by Bureau of Energy Efficiency, which basically makes it more stringent, has more focus on the infrastructure for the implementation of ECBC guidelines, and also certain standards and processes for monitoring the progress and implementation of the ECBC code. Hypothetically, if ECBC was implemented in 2007, savings would have been 4.3 billion electricity units and 30 million metric ton reduction of CO2 emissions. ECBC 2017, the primary objective is to provide minimum requirements for the energy efficient design and construction of buildings. The scope is for both the commercial building as well as residential building. Right now, it has been made mandatory for commercial buildings which have a connected load of 100 kilowatt or greater, or a contract demand of 120 kVA. Whereas for residential buildings, the ECBCR has been introduced, but has not been made mandatory, and but it is likely to become mandatory in the near future. There are three levels of compliance: ECBC Basic, ECBC Plus, and Super ECBC. Basic level compliance is being made mandatory, and ECBC Basic should give an energy saving of 25% to when compared to a typical building. ECBC Plus should give 35% energy saving when compared to a typical building, and Super ECBC should give 50%. Now, there are two methods of achieving ECBC compliance. The first one is whole building performance method, and the second one is prescriptive method. In whole building performance method, basically it has been left to the project owner to decide on how to configure the projects and the various elements to achieve the basic compliance mandated by ECBC, and guarantee an energy saving of 25% minimum over a typical building, which has to be attested by energy simulation software approved by B. So here the prerogative and lies with the project owner to do what he finds more convenient and more feasible for them. Uh, Whereas in prescriptive method, uh, uh, there already exist standard and specifications for various elements of the buildings, which a project owner has to meet to comply to the ECBC basic standards. Say, for example, for the building envelope, for the roof as well as for the terrace, there are certain U values defined which a project owner has to meet to take the ECBC compliance. Now, as Pidilite, we prefer and recommend prescriptive method over whole building performance methods, because mainly we feel that this is much easier to comply with, because the values are are already given. They are easy to achieve. They can be achieved uh, by by the simple process, by the materials which are already available in the markets. Also, because it is already specified, the absolute value are specified, then it is easy to implement it and measure how much value has been we have got. And especially this is very good way to achieve compliance in case of retrofit building, where the project owner doesn't actually have to make any changes to the structure of the building. They can just put it on the facade and on the roof and achieve the basic compliance. So by prescriptive method, depending on the area and what a zone the project falls into, has specified certain U values to for roofs as well as for walls, which are given here. So there are basically five climatic zones: composite, hot and dry, warm and humid, temperate, cold, and different type of buildings, and they are already prescribed. So I believe Karnataka is the only state where all five climatic zone could be found. Now, Pidilite offers solutions both for wall as well as for roof for meeting ECBC compliance. So, for the roof, we have a low energy consumption systems which we offer for the roof, which includes both the product as well as the execution. So basically, the project owner has a scope to take different type of material at different U values, different thickness, different waterproofing guarantees. We actually probably we are the only company which offers 25 years waterproofing guarantee, and it is possible to meet and achieve much lower U values uh, compared to the prescribed U values for roof by going for Pidilite LEC systems. As for walls, we offer EIFS with in collaboration with our joint venture partners, Grupo Uma Spain, who have extensive experience in the product development, in the execution, and they have done projects, and we have lasting for more than 20 years, and with multiple facade options, beautiful architectural finishes. So we will be offering EIFS for the wall insulation. And to talk about EIFS in details, I invite my co-presenter and partner Pepe. And once again, thank you for giving us this opportunity. Pepe, please take over. Thank you.
Thank you, Prasad. As we have seen all this information, we have decided to develop a new thermal isolation system. We are going to see why we decided to make an EIFS. Which are the main advantage of EIFS systems? Okay, first of all, the main studies of energy saving of buildings says that most of the losses of energy in buildings comes from across the walls of the building. The 40% of losses of energy goes through the walls. That's why we decided to develop a thermal isolation system for walls. This kind of systems will not be an expense, but a profitable investment. In a short time short term of time, we will recover the amount we will spend in the installation of the system by the economy in heating and refrigeration energy we will reduce thanks to the installation of the isolation system. As is a system installed outside the building, it has several advantages in renovation of existing buildings, because the installation of the system doesn't affect to the habitability of the building. So the use of the building, the normal use of the building, can continue meanwhile we are installing the system, the isolation system. And in addition, we are not losing any space inside the building. We keep all our space because all the components of the system are installed outside. Okay? As this system works as an envelope of the building, we are not only isolating the thermal, getting this thermal isolation of the building, but also we are protecting all the structure of the building, all the materials of the structure of the building, because we are protecting it from the weather agents, the wind, the rain, the change of temperature. All this doesn't arrive to the components of the building, so we are making the life of the building longer. All the components of the system and the system itself are waterproofing and are also permeable to water vapor, so they breathe the building. As there is an external isolation, we eliminate all the thermal bridges we have in non-isolated and even in buildings isolated inside, okay, because we have these thermal bridges in the slab of the building, and with our EIFS we don't have this kind of thermal isolation that can give us this kind of problems. So we avoid these problems of molds inside the building because of the thermal bridges and the difference of temperature between inside and outside of the building. And as if it's an outside installation system is installed in the facade of the building, we are not only getting this thermal isolation, but also we are renewing aesthetically the facade of the building. So we are improving the value of the building. Okay. So we have decided to do this EIFS system. We are going to see now the main characteristics and components of this traditional EIFS system. As a system, we are offering all the components to the market. Pidilite Grupo Puma not only has the mortar and the finish or the panels, but all the complements and all the necessary complements for the installation of the system. The installation is very simple. We place, first of all, the starter profile, fixing it directly to the wall. We will place the first line of panels over this profile, which marks the starting line of the system. We will fix the panels to the wall by using the special mortar, fixing all the panels to the wall. After that, we will improve this fixing of the panels by installing the trading anchors. We will make a panel sanding to uniformize, to homogenize the absorption of the panels, to improve the adherence of the coat of mortar we are going to apply now. And we will cover all the anchors with mortar. And after that, we only have to apply the coat of traditional mortar This is a more or less 5 millimeters coat with a mesh, reinforcement mesh inside the coat of mortar. That will give us all the mechanical resistance we need in the system. And we will finish with Mortenkrill Fondo primer and Mortenkrill acrylic mortar, which gives us the aesthetical finish in addition to waterproofing and protection of the facade. This is a 5 millimeters mortar, which gives us an aesthetic finish with a wide range of colors. So the first component, the main component, is the mortar. We have 3 kinds of mortar. First mortar is Traditerm standard, is the most commonly used mortar, and we use this mortar for fixing the panels to the wall and to cover these panels with a render of 5 millimeters more or less of this mortar. This mortar is a waterproofing mortar, is a breathable mortar, is permeable to water vapor, so it leaves the building breath, and is specially formulated to fix this kind of panels, isolation panels. So adherence is very, very good. This mortar, all the components of the system follows the European standards. So we check all the quality controls in order to follow all these standards. The second one is Traditerm projectable. It has the same characteristics of Traditerm standard, but in addition, we can make the application of this mortar by using a projection machine. So we make a faster application when we reduce the time of application of the system. For big buildings, is a good option if we have the machine. And the third one is Traditerm flexible. This is a flexible version of our mortar. It's a cement-free mortar. It's ready to use, and we recommend this mortar mainly for the flexible version of Traditerm system we are going to see later. Second component is the isolation panel. That gives us the isolation, thermal isolation of the system. We have 3 different isolation panels. The first one and most commonly used one is EPS panel. Is a high density EPS panel. We have it in different thicknesses depending on the level of isolation we are looking for, and is a good solution for thermal isolation because thermal conductivity of this material is between 0.036 and 0.038. So this brings us a very good level of thermal isolation. Second one is mineral wall panel. Thermal properties of this panel are very similar to EPS panels, but in addition, this panel has properties of resistance to fire. So it's commonly used in projects where we need this special protection because the size of the building or the use we are going to do with this building ask us to improve this fire protection. And the third one is the XPS panel. This kind of panel has some advantages comparing with the others because mechanical resistance are a little bit bigger because it's a more rigid panel, and isolation level is a little bit higher than EPS or mineral wall panels. Not so much, but a little bit more. But in opposite of this, since these are very rigid panels, we cannot use them if leveling of of the substrate is perfect. It's not perfect. If we don't have a 100% leveled substrate wall, we cannot use this kind of panels because we can have tensions which develop crackings and problems in the future. The installation of these panels can only be made by the notched travel system and not by the core system because of the same. We need a perfect wall and continuous layer of adhesive. And the third component of the system is the finishing. We recommend as finished this acrylic mortar. We have different versions of acrylic mortar too. First of all is the primer. We use this primer, this Mortencryl Fondo, as a primer to homogenize the absorption of the system, of the substrate, of the mortar we have applied before. And as this is a colored primer with the same range of colors of the acrylic mortar, we reduce the amount of acrylic mortar we will need after to cover the surface. After the primer, we can use different kinds of acrylic mortar for finish. We have a standard Mortencryl standard, is the most commonly used one. Is an acrylic mortar, cement-free, is waterproofing and breathable as the other components of the system. We apply in 5 millimeters, and with this layer of 5 millimeters, we have the necessary waterproofing or rain of the building. There are a wide range of colors we are going to see, and it's easy to apply. 100% compatible with the Traditer mortar. In the lower part of the building where it's more attacked by people or traffic or so on, we can apply this second kind of mortar. Is Mortencryl Mosaico with the same characteristics of waterproofing and breathability of Mortencryl, but with more mechanical strength than the normal Mortencryl. And the third kind of acrylic mortar is Mortencryl Flexible. This is a special formulation of acrylic mortar, especially recommended for the flexible version of Traditerm system, and it has the same characteristics of Mortencryl or Mortencryl Mosaic in order of waterproofing and water vapor transpiration, but is also more flexible. So we will use in situation where this flexibility is necessary. This is the color range of Mortencryl, Mortencryl Flexible. We have a wide range of colors, and this is the range of colors of Mortencryl Mosaico. And in addition of all these main components of the system, we have all the complements necessary for the installation of the system. We have this Traditer mesh. We have talked about this mesh. Is the mesh we place inside the layer of mortar to improve the mechanical resistance. The aluminum starter profile we use to start the system, place the first line of panels. Traditerm anchors to improve the fixing of the panels to the wall. The Traditerm guttering profile with mesh, and the Traditerm PVC corner reinforcements with mesh. This kind of profiles to protect all the corners of the building and to avoid several aesthetical problems of dust in the wall. Traditer window finishing profile to use in the joints between the wall and the windows to make this kind of joints. Traditerm joint treatment profile to cover the joints, the structural joints of the building. And Traditerm crowning profile is a profile we place in the top part of the system to protect from the rainwater. So combining all these components and complements, we find different versions of Traditerm system. The first one is Traditerm EPS XPS. It's the basic one, is the most common used one. Here in this version of the system, we are using Traditerm or Traditerm projectable as a mortar for fixing the panels and for covering the panels. We are using EPS and XPS panel, EPS or XPS panels for the thermal isolation. And we finish the system with our Mortencryl Fondo and Mortencryl or Mortencryl Mosaico. The second one is Traditerm Mineral. Is the same as the Traditerm EPS XPS, but we are using mineral wall panels instead of EPS or XPS panels. Here we obtain this fire resistance we may need in several projects. The third one is Traditerm Flexible. We will use this version of Traditerm system when we expect our building is going to suffer high attacks from weather, in big changes of temperature, or we expect the structure of the building can have little movements. So we use this flexible version of the system to absorb, to avoid crackings or problems from these little movements. In this system, we use Traditerm as adhesive to fix the panels. We use only EPS panels in this kind of system, and we render the panels with Traditerm Flexible. And the finish will be done with Fondo Mortencryl and Mortencryl Flexible too. And the last one is a version of Traditerm EPS system, but with tiling as a finish. So we are going to finish the system not with acrylic mortar, but with tiles. We will use a special adhesive for this application called Traditerm Ceramic, and to improve the adherence, to avoid problems the cooling of tiles in the future, we are going to apply a double layer of Traditerm mortar before the finishing. So we have a double application of Traditerm with mesh, and after that the finish with the tile. All these systems, all these versions of systems, and all the components of the systems follows the European standards. The IOTA is the organism which controls the quality of these kinds of systems in Europe, and the ETAE is the document which certifies all the properties of the system for the thermal isolation and all the characteristics of waterproofing, breathability, and all the other characteristics. All the components are also follows the European standards for the different kind of mortar or the different kind of material we are using. In addition of these characteristics of these products and components and systems, Pidilite Grupo Puma offers several services to the Indian market to complement the system itself. We have a very trained technical team which works both in our R&D department, developing new finishes of the system and looking always for how to improve the characteristics of our thermal isolation systems. We have also a specialist in application team who give all the professionals enveloped with the installation of these kind of systems, the assistants, the work assistants, so they can explain the technician which version of the system is the most adequate for the application or for the project they are developing. Or any assistance they need in the design of the system. And we are also applicators which can help and assist the people who are going to install the system in the building about how to do it in the best way for not having any problem. As this kind of system have been applied in Europe for many years, we have a lot of projects done with our Traditan system, and we have documentation about all these projects. We have technical reports where we have all the information, technical information of the different projects made with our system, and this information can be used for the technicians who are going to use to include our system in their projects. We have also constructed the tiles and BOQs and a lot of information and documentation to help to make the technicians' work easier when they decide to install this kind of system in the building. And I wanted to show you some examples of buildings applied where they have used this kind of system. So you can see different kinds of buildings where it can be used, different finishes and different materials of isolation panels can be used in this project. And that's all. I hope it has been interesting for you. Thank you very much for your attention. And if you need any other information about this or any other product or system of PD Light Grupo Puma, you can contact us in the email you can see in your screen. Thank you very much for your attention and see you soon.
Good afternoon, professionals. My name is Samir Sullakar. I belong to construction chemical industry. I complement CIDC for this India Construction Week 2020 with the aim of revival of economy. We are largely dependent, or we are directly dependent on construction industry, as we are manufacturing the construction chemicals. I shall give you a brief introduction of construction chemicals, the industry overview, some efforts, some problems that we are facing, and some efforts that we have already done uh, to revive it within our limited means during this pandemic times. This is the basic agenda: the introduction, the industry numbers, the key trends, the action taken, and conclusions. Construction chemical industry is a industry basically which manufactures construction chemicals with the whole purpose of solving the problems during the construction, during the surface life, and even going to the stage of repairs and rehabilitation. So we are connected to each and every stage of construction per se, and our aim is to increase the durability of concrete, which is also proportional in a way to the sustainability, and to improve the constructability. Whichever type of concretes are required, which are not possible to do otherwise, we use chemicals to make the constructability and the construction more viable, more green, and more sustainable. We belong to, we are categorized in specialty chemicals. We are civil engineers, or we are engineers who know about chemicals, and we are chemists who know about concrete. We devise the solutions. In fact, this industry grew from the solutions. Those are asked of us by the construction industry. They wanted a self-compacting concrete, so we had to give them a concrete which compacts by itself. So we have to go in and manufacture that particular chemical which aids the making concrete self-compacted. Ultimately, the whole aim is to make the concrete more sustainable, more durable, so less recycling, so that the environment is protected. Our expertise, as I said initially, is a concrete enhancement. We help during construction, concrete repair, when the concrete is exposed to difficult conditions, we repair the concrete, and to avoid the repairs and to make the concrete durable, we have got third and the most important function is the concrete protection. Traditionally, we are sandwiched between two big industries. On one side, there is the construction material industry, like cement, minerals. This is a very large industry, the large players. And then there is a traditional chemical industry, which is also equally large, because all our raw materials, cement is also our raw material, minerals are also our raw materials, chemicals are also our raw materials. So in both the cases, all our raw materials, all our inputs come from large multinationals or large organizations. And we as construction chemical industry are basically, our technology is the formulation technology and mixing and blending technology. We provide solutions by combining these both things. So we are sandwiched between all big companies, and we create the values. We create the values. We create a value addition. We increase the efficiency of construction, so the construction becomes more economical. We increase the strength of concrete. So we make very small elements, very small dimension columns, and we can build, save a lot of space to the builders. We make the concrete beautiful. We make the concrete aesthetic. When you use construction chemicals, you also can get a good surface. So we can even go to the extent of making a fair faced concrete, which looks very beautiful. It is gray and it is concrete. Safety, it is one of our most important things that we provide. We protect the structures. Protection of structures is very important in these times of pollution, and to reduce, to do a perpetual maintenance and to reduce the costs of repairs. Protection and maintenance are one of the very important steps that our industry should take to save the resources. We increase the span of the building by giving it protection or by repairing it, which increases automatically the life of the structure. So the life cycle costing becomes less. And most important is what we are doing very recently. I will not say very recently, but few years back, we are making the buildings energy efficient. We are having insulation. We are having insulation systems, which when applied to the construction, can save your cost on electricity. It can reduce the temperatures in the habitat, in the living areas, and this is a large contribution. This is a large, we save the air conditioning costs. This helps the sustainability on the whole. Just few numbers. As per some latest data which has been taken from internet, our market size is approximately 9,000 crores, 9 to 10,000 crores. The growth rate, which was supposed to be or estimated as 17% CAGR, due to COVID, it is a little bit less, 9%. Hopefully, if we can achieve it, it is very good. There are about 500 to 600 players, known players, and there are still hundreds of more, which are not known, or we do not exactly categorize them because they make a single product, like a single waterproofing compound. The companies involved in construction chemicals are from a wide range. That means we have companies which are 100% subsidiaries of multinational companies, which are manufacturing construction chemicals all over the world. We have large Indian companies. We have large paint companies manufacturing construction chemicals. We have 100% Indian companies who are also manufacturing construction chemicals with their own technology. We have foreign collaboration companies. These are joint ventures between the Indian companies and the foreign companies. We have MSME and small scale industries in this sector. So what happens? This whole market is to be catered by all this type of companies having different constitutions, and that gives this particular industry a lot of difference compared to the other industries. Just to give a data, like the turnover of top 10 companies is about 50% of the total turnover of the industry. As far as the growth is concerned, and just to relate it with the global growth, from comparing the time era of 2015 to 2020, is a very big industry globally. It is some 120,000 crores industry, whereas in India it is 4,225 crores. This is way back in 2015. The growth rate internationally has been only 6.5%, 6.4% per annum, whereas the growth rate in India has been 13% per annum. In 2020, we have reached worldwide about 180,000 crores, whereas in India, we are about 9,000 to 10,000 crores. That means we are growing much more than than the other world. The reason being, we are still an economically developing country with sound education, sound, very good resources, whereas other countries like in Europe and America and all, they're more or less stabilized. So this industry is called a sunrise industry. We have got a lot of growth potentials, and there's a wide gap to be achieved between what is really the industry is and what the industry can go to. This has brought in so lot of foreign players as well as the Indian players, and the industry has seen some significant mergers and acquisitions and takeovers of the existing Indian companies. This trend will continue in the days to come, because as the market grows, the larger companies will like to be a part of the game or the part of the industry. And in about 2025, we are hoping that this market capitalization will be about 15,000 crores. The effect of COVID on the whole numbers, because these numbers are coming from a particular private source, which is also available on the net. It is a study of construction chemical industry in India. It may change slightly or considerably depending upon the length of the conditions we are having. These are the market segments, global versus India. Just to give one or two examples, the consumption of admixtures in India is about 40%, 39%, whereas the consumptions in India is out of India is 26%. This shows that our construction industry or our constructions are growing with respect to what is going on all over the world. Our repairs and rehabilitation is about 10%. Still, it is on the lower side. It should be more. Whereas internationally, it is only 2%, which also means our structures are not that well protected as compared with the global industry. I think this comparison will really lead you to find out where are the gaps in the industry and fill it. As far as the products are concerned, as far as the growth of industry is concerned, flooring, similarly, to come back, that our floorings are about 9 to 10%, whereas international flooring is only 2%. Once again, shows that our industrialization, flooring mostly goes in the industrialization, is far more than the other countries. That is, we are a growing economy, and we have a lot of prospects for the growth of construction chemical industry. Segment wise, about 24% go into commercial buildings. We are dependent on real estate. About 31% materials go to the residential. So this is quite a big sector. So if this is reduced, and the public buildings is about 3%. So this constitutes to about 34 plus 24, about 68%. So if the buildings and the real estate industry takes a hit or goes down due to this economic conditions, our industry will take a direct hit. The infrastructure takes about 27%. Fortunately, we are very strong in it. The projects of building our national highways, our national resources, metros, and dams and other hydroelectric projects is going on uninterruptedly. And this is a very, very positive thing. This industry can contribute tremendously to this infrastructure and the growth. Few trends: the rising consumption of the population. We have schemes from government, PM via Awas Yojana, which will give a lot of housing, which will indirectly benefit the construction chemical industry. There's urbanization. There is a trend that the people from villages are slowly coming to the cities. So with this urbanization, new structures will come, new markets will come, new infrastructures will come, which will lead to a growth. Resource utilization, compared to other parts, India is a very, very vast area country, and the land covered by construction is very less. It's about very, very less compared to other developed nations. A lot of investment is coming into the IT industry, as well as a lot of investment is coming in the health industry. Every industry at the end of the day will need construction or needs the constructions, and that is the advantage of our industry. In whatever constructions, our industry has got an entry inside. Growth drivers: increasing investment in infra projects, growth in urban housing, increase in FDIs leading to the boost in industrial sector, repairs of the if existing infrastructure. This is a tremendous market, unbelievable market. And if we start taking the cognizance of these repairs to retain the durability of to increase the life enhancement of our civil engineering assets, this would contribute tremendously to the construction chemical industry. Where regulatory environment for the environment is there, and increasing compliance with the, we are playing with the international players, so that too is a growing trend. There are limitations. Which are the limitations? Limitations, as I said in the beginning, that our industry is sandwiched between the giants, whether it is for the cement, minerals, and or it is for the raw materials. So we are in between. Our suppliers are top level companies. So we have very less control on raw material pricing. When we are selling to the larger companies, they have a tremendous bargaining power. They need tremendous terms for financial terms in terms of credit, and we have to provide it. Whereas the industry, as I said, ranges from multinational companies to MSMEs. So this is one of the very restraining factor. Credits and payments. Now this brings us into the, especially the small players. This brings us into the uh, cash flow troubles. Then there's a competition from unorganized sector. Unorganized sector is a sector which is neither they are members of our associations, nor they are in the mainstream, but they manufacture some one or two products, and purely by virtue of their personal contacts and purely by virtue of their pricing, they still enter the market, and they keep on growing. There's a lack of awareness. The customer is not very much aware of the materials and where they are to be used, and this is a big restraint which we try to fill up. I'll just come to it. And lack of adoption based on the price concept. This is one of the main things. These are the challenges which we met. How we met up? The main challenge is the low barriers to entry. With a small capex, with a small capital investment, you can start a construction chemical company. Many of the people who were initially working in the construction chemical, they got their own factories. Many of our raw material supplies, like that of sand, they are now the manufacturers. There is lack of skilled manpower, which we are ordered, which I think our CIDC will be covering in the skill development. This is very important. It's a highly fragmented market. It is going from villages to the cities. We have low base material consistency. If we don't go to the multinationals and if we go to the local suppliers, then the consistency of the materials is not there, leading to not very good product at the end of the chain. There's a high price sensitivity. Everyone is bothered about money. There are auctions. There are ways where people want to reduce your pricing to minimum. And there is a low acceptance of high-end systems. This is very important. People are not very keen to calculate the pricing on cost cycle. People are more interested in calculating price of the initial price, per kilo price, not considering the durability, not considering the length of the time the material is sufficient. So we did overcome the challenges? We made attempts to build awareness, work in partnership with maybe small companies, make them partners by getting materials manufactured from them, drive the specifications higher to be a part of the codes, to part of the government committees, and therefore contribute so that the standardization comes directly from the top, and to leverage the core expertise. To this effect, we formed an association called Construction Chemical Manufacturers Association way back in the year 2012. This is an association, this is an apex body which represents most of, but a very small portion of the construction chemical manufacturers who are really interested, in coming to a forum. In coming to the forum, they are really interested in making the product as per the international standards. They are really interested in being part of the industry to bring in awareness. So we have about 60 members. If you see the top names will be the part of the organization. So these people have been already working for past 7-8 years, and Construction Chemical Manufacturers Association have done a lot of efforts to bring in the awareness. whether by means of presentations, whether by means of webinars, seminars. These are the actions which we have taken. Training programs for the end users, training programs for the construction chemical industry so that they become aware, tie-ups with professional bodies for documentation, conferences, seminars, national and regional. We have done both of them, working with BIS, CIDC, Engineering Council of India, development of codes of practice, which is coming slowly, but still it is coming. We are getting standardized. Development of handbooks. Indian Concrete Institute has done a tremendous efforts, and now the handbooks on admixtures and handbook on uh, waterproofing is almost seeing the light of the day, and we already have handbooks in ECI on precast in ICI in precast construction as well as industrial floorings. So a lot of work has been done by the professional bodies, and this standardization is coming. Creation of awareness slowly compared to 20 years back when I, or 30 years back when I entered the country, the awareness level is today quite high, and industry standards are also increasing. The international players are coming in, international standards are coming in, and hence uh, more and more standardization is coming in, and the acceptance of the high standard products is more acceptable as of today. So we are learnings, what we are learning, or what are the conclusions? We are a part of the construction industry. We can affect the sustainability and durability. We can bring the speed and economy and eco-friendliness. Needs still more efforts in increasing the awareness. It is a mature but slowly expanding industry. We should directly go into the specification. It needs a better further organization. We need a stronger organization. Many people, many more people to come and join this movement. More increase or faster codal developments and handbooks. Academicians and professional train academics and professional training. This is coming up in a very very nice way. The IITs and the other top level bodies, they are trying. AICT is involved. CIDC is having skill developing. So this is going on. Of course, we need a government support at the end of the day. Government support at the end of the day to bring in more standardization, more awareness, and as we said, and and as I mentioned to start with, to sum it up in the conclusions, we will need a lot of support from the government with respect to the liquidity, with liquid to standardization, with respect to the skilling, and in addition to all the efforts that we are doing, help from CIDC, help from ECI will be very much appreciated. We shall definitely come out of this times. And once again, I thank CIDC for making this initiative to revive the economy in these times. Thank you.
Namaskar. Welcome to India Construction Week 2020, an online international conference and exhibition being organized jointly by Construction Industry Development Council (CIDC) and Indian Society for Trenchless Technology (INDSTT) from 1st to 5th December 2020. The central theme of this conference or event is reviving construction industry in post-COVID world. COVID-19, as we all know, has brought in its trail major disruptions. Construction sites and construction processes across the world are disrupted. Shortages of manpower, material, machinery has been rampant across sites. Supply chains have been disrupted. Work has gone, or human life itself was under lockdown for a considerable period of time. As we now stand in the unlock phase where the global economies are opening up and embracing change, a pertinent theme for this conference is emerging technologies in construction and infrastructure. I, Ashutosh Bhardwaj, Director, Corporate Affairs, Construction Industry Development Council, have been one of the coordinators for the 28 sectional committees that have been formed, and one of them is Emerging Technologies in Construction and Infrastructure, which I am coordinating. We've been lucky to have Dr. P.R. Swarup, Director General, Construction Industry Development Council, as the chair for this sectional committee. And we are also very fortunate to have a broad-based and all-inclusive sort of participation from major organizations like RailTel, GR Infra Projects, NHAI, L&T, KMV Projects, Hilti India, GP Global, Access, Assess Buildchem Solutions, PMS Engineering, Apple Chemie, Trio Elevators, MSV International, Global Aluminium, Structural Engineering Research Center, Sudhakar Pipes, Twasta and Algo 8, to name some of a few, who have devoted a lot of time and energies over the last 4-5 months and participated in the sectional committee meetings which were held online and which has culminated on in today's agenda. And the agenda, as we are saying, that we need to look at sustainable construction practices in the post-COVID world if we need to revive the construction industry and to carry it forward. They have been curated and chosen with care so that all of you are able to have a flavor of the new and emergent technologies which will be relevant in the coming times. Now, we've all heard of these technologies which are now embracing the construction space. Construction space, as you feel, in India, that was the most badly hit sector. Now, one of the prime reasons why construction sector has been one of the most badly hit sectors during the pandemic is the low absorption of technology per se in the sector, which also indicates that we in the sector need to be more open to change, more open to embracing new technologies and moving forward. In case in future, God forbid, it should not happen, but in case such exigencies or such unprecedented situations do happen, then technology would be one of the saviors, as this pandemic has taught us. So we have certain themes playing out during the conference in this particular section, Emerging Technologies, which are basically precast and the challenges ahead, primarily with jointing of the precast and how basically these can be circumvented. We have increased use of geotextiles, we have 3D printing, we have machine learning, we have industrial Internet of Things, we have artificial intelligence, we have dust-free construction, we have asset management and tracking solutions. So majority of these themes, basically they are being looked in silos at the moment, but then what we need to do is sit and join the dots. So the challenge is not only the technology per se or how we embrace it, but it's also joining or connecting the dots and how they can play out in tandem, so that a demonstrable model for the industry is created, which is replicated by the others. So with that challenge, basically all of us have thought through, we have discussed, we have deliberated, and we bring together you this theme, which I am sure you would like. And just to add on, basically these sectional committees, the 28 sectional committees which have been formed for this event, they are sustainable. What I mean to say is that beyond this, post this event, which is 5th of December, these committees would remain functional. And we would be holding webinars, we would be basically deliberating on new themes, and all of you are encouraged to basically participate, come up with ideas, come up with suggestions, and do share them with us. You have the conference mail ID, you can mail it to them. Even the speakers who are going to basically present during this conference, we would be sharing their mail IDs, their numbers, and you can connect to them, and whatever questions you have, otherwise you send it to the secretariat, and we will keep engaging with all stakeholders who are participating in this conference over a longer duration of time. So I wish all of you a very engrossing and engaging time in the emerging technologies sessions, and thank you so much for your participation, and wish you all the best. Thank you.
Very good morning to all of you who are present here today. Very good morning to all of you who are present here today, and we are fortunate to have a galaxy of wonderful speakers who have come out with the new technologies. And the name of the session, as you are all aware, it is about emerging technologies. In this particular period of time, very good morning to all of you. Lifestyle has changed, and the way we are going to be doing things
Namaskar.
in the future, that also is now changing very rapidly, and we are learning the ways how to basically do the things and how to basically reinstate our construction industry and of course the rest of the manufacturing industry. I think the role of emerging technologists and the technologies is something which is of utmost importance. I really thank all the wonderful speakers who have come today, and they will be displaying the kind of models and the kind of work that they have done, which is going to be beneficial to all of us. We can pick and choose out of the things that are there. We'll be talking about the new. Very good morning to all of
Namaskar. Welcome. India Construction Week 2020, an online international conference and exhibition being organized jointly by Construction Industry Development Council CIDC and Indian Society for Trenchless Technology INDSTT from 1st to 5th December 2020. The central theme of this conference or event is reviving construction industry in post-COVID world. COVID-19, as we all know, has brought in its trail major disruptions. Construction sites and construction processes across the world are disrupted. Shortages of manpower, material, machinery has been rampant across sites. Supply chains have been disrupted. Work has gone, or human life itself was under lockdown for a considerable period of time. As we now stand in the unlock phase where the global economies are opening up and embracing change, a pertinent theme for this conference is emerging technologies in construction and infrastructure. I, Ashutosh Bhardwaj, Director, Corporate Affairs, Construction Industry Development Council, have been one of the coordinators for the 28 sectional committees that have been formed, and one of them is Emerging Technologies in Construction and Infrastructure, which I am coordinating. We've been lucky to have Dr. P.R. Swarup, Director General, Construction Industry Development Council, as the chair for this sectional committee. And we are also very fortunate to have a broad-based and all-inclusive sort of participation from major organizations like RailTel, GR Infra Projects, NHAI, L&T, KMV Projects, Hilti India, GP Global, Access, Assess Buildchem Solutions, PMS Engineering, Apple Chemie, Trio Elevators, MSV International, Global Aluminium, Structural Engineering Research Center, Sudhakar Pipes, Twasta and Algo 8, to name some of a few, who have devoted a lot of time and energies over the last 4-5 months and participated in the sectional committee meetings which were held online, and which has culminated on in today's agenda. And the agenda, as we are saying, that we need to look at sustainable construction practices in the post-COVID world if we need to revive the construction industry and to carry it forward. They have been curated and chosen with care so that all of you are able to have a flavor of the new and emergent technologies which will be relevant in the coming times. Now, we've all heard of these technologies which are now embracing the construction space. Construction space, as you feel, in India, that was the most badly hit sector. Now, one of the prime reasons why construction sector has been one of the most badly hit sectors during the pandemic is the low absorption of technology per se in the sector, which also indicates that we in the sector need to be more open to change, more open to embracing new technologies and moving forward. In case in future, God forbid, it should not happen, but in case such exigencies or such unprecedented situations do happen, then technology would be one of the saviors, as this pandemic has taught us. So we have certain themes playing out during the conference in this particular section, Emerging Technologies, which are basically precast and the challenges ahead, primarily with jointing of the precast and how basically these can be circumvented. We have increased use of geotextiles, we have 3D printing, we have machine learning, we have industrial Internet of Things, we have artificial intelligence, we have dust-free construction, we have asset management and tracking solutions. So majority of these themes, basically they are being looked in silos at the moment, but then what we need to do is sit and join the dots. So the challenge is not only the technology per se or how we embrace it, but it's also joining or connecting the dots and how they can play out in tandem so that a demonstratable model for the industry is created which is replicated by the others. So with that challenge, basically all of us have thought through, we have discussed, we have deliberated, and we bring together you this theme which I am sure you would like. And just to add on, basically these sectional committees, the 28 sectional committees which have been formed for this event, they are sustainable. What I mean to say is that beyond this, post this event, which is 5th of December, these committees would remain functional. And we would be holding webinars, we would be basically deliberating on new themes, and all of you are encouraged to basically participate, come up with ideas, come up with suggestions, and do share them with us. You have the conference mail ID, you can mail it to them. Even the speakers who are going to basically present during this conference, we would be sharing their mail IDs, their numbers, and you can connect to them, and whatever questions you have, otherwise you send it to the secretariat, and we will keep engaging with all stakeholders who are participating in this conference over a longer duration of time. Namaskar. Welcome to India Construction Week 2020.
Very good morning to all of you who are present here today, and we are fortunate to have a galaxy of wonderful speakers who have come out with the new technologies. And the name of the session, as you are all aware, it is about emerging technologies. In this particular period of time, when the lifestyle has changed and the way we are going to be doing things in future, that also is now changing very rapidly, and we are learning the way how to basically do the things and how to basically reinstate our construction industry and of course the rest of the manufacturing industry. I think the role of emerging technologists and technologies is something which is of utmost importance. I really thank all the wonderful speakers who have come today, and they will be displaying the kind of models and the kind of work that they have done, which is going to be beneficial to all of us. We can pick and choose out of the things that are there. We'll be talking about the new methods of construction, the new project management methods. We'll be talking about the new materials of construction, the new, the methodologies, and exactly how are we going to be grooming young people who are going to be taking over the industry from us in a different manner altogether. So you have plethora of things that will be discussed today. ICW 2020, as you know, is an effort which is being made by CIDC jointly with Indian Society for Precious Technology, supported by many organizations in the state government, and with the best wishes of everyone who is concerned to make sure that construction industry again moves on the path of revival, and this revival is extremely important for reinstatement of the economy, to generate and create the new opportunities of employment for our youth. And I am absolutely confident that the old methods that we have been following until about beginning of this year, 2020, are going to be changing now. And what are the new dimensions of the work? Best wishes of everyone.
Hello friends, I am Vivek Naik.
Sure that construction industry again moves on the path of revival, and this revival is extremely important for reinstatement of the economy, to generate and create the new opportunities of employment for our youth. And I am absolutely confident that the old methods that we had been following until about beginning of this year, 2020, are going to be changing now, and what are the new dimensions of the working, that is something that will emerge out of it. There are several other issues on which we will be deliberating, and you can see the total program, and my encouragement to all of you is to also go and visit other rooms and participate in other programs, observe them, learn about the new things that are being spoken about. There are dedicated sessions on various very topical issues, and I'm very sure that these are all going to be of great use to all of us who are participating in there. With thousands of participants in this particular event and exhibitors that we have here, probably ICW 2020 is going to be the biggest ever event that has taken place, and especially for the construction industry. We hope that the tradition will continue. We'll continue this interaction, and we have decided to keep the whole recordings hosted on our portal for a considerable long time, so that the professionals, the practitioners, and especially our students, engineering students who are here in very large number, they will be in a position to get the benefit out of it, and that what is basically the kind of objective of this particular event. There are going to be sequel seminars, sequel workshops that will be conducted on the basis of deliberations that are going to be made here. We have made a special arrangement for the participants to come back with their queries, get the answers, and seek the kind of solutions from some of the finest experts in the country and outside also. There is a host of international organizations who are today sitting with us and helping us out to make sure that this event becomes truly a memorable one. We have people from almost all corners of country, our neighboring countries for that matter, and I am absolutely certain that the message is going to go far and wide that Indian construction industry is taking all the possible steps to make sure that we continue with our business, we fight it out with the pandemic, and we again regain the normalcy in life. Of course, we all know that it is not going to be pre-2020 kind of a situation, so there are new methods, but with the resilience and the kind of will to fight, I am absolutely certain that we in India will not only be able to solve our problems, but also showcase some of the models which might be available for emulation to people around our geographical region. I wish a great success to all of us and pray to God that we keep our health intact, we follow all the safety precautions and measures, and remain healthy and live as long as the God wishes. With that, I bless all of you and thank you so much for participating. You have done us a great honor. INDSTT and Construction Industry Development Council, along with other organizers of this particular event, are very obliged to you. Our sponsoring organizations need a special thank that in spite of all the difficulties and the kind of economic disparities that we have, they have come and wholeheartedly supported us. Thank you very much. God bless us all.
Hello friends, I am Vivek Naik, and today we are going to talk about India Construction Week after COVID. Specifically, we are talking about construction industry after the COVID scenario. Well, I don't mean that COVID is over, but yes, there is a transformation of the lifestyle because of the impact of COVID all over, and how we carry forward ourselves in the construction industry very successfully will be our aim. If you see the COVID scenario all over the world, and especially in the construction industry, many things have changed. Projects under planning have a different impact because of the economy, government rules, and preparation methods for the new projects. The projects which are already under the construction have got a severe impact because of the constraints of financial inflows, constraints of workers, skilled workers, and many resources. Some of the resources which were used in the construction industry have practically gone out. And the assets which are under the operation, we have to check up and verify today whether the planned resources and planned liquidity will come in the same fashion, or will it meet with again liquidity crisis. So this is a big scenario and we have to tackle it in a different manner. If you see, there had been pandemics in the past also. You can take a case of Ebola, MERS, SARS, or even bird flu. But in my thinking process, they were local or regional. But the widespread impact of COVID-19 is phenomenal. It is having a severe impact today and will be having a lot of impact in the future also. The common issues can be workforce and the workforce leaving the territory. The cost of workforce obviously will be going up. Supply chain, yes, there will be delays, there will be disputes, there can be problems with the incoming material and the utilization pattern of it. Sales will decline and are declining. Cash flows obviously are getting affected. And the operational point of view, if you see, the reduced resilience and the key fundamentals are vanishing. There will be some new line of thought process coming as far as the operations are concerned. Take a case of even travels. Airline industry is hampered, people cannot reach. Buses are operating in a different fashion, so as the railways. So right from the communication and the commute of people to the project and construction industry is going to be different. Not all the regulations of regulating bodies, government regulations challenges their cash flows, IT finances, and even you see the legal proceedings. They are trying to have their interactions from home. So all this scenario is a very different and not expected at all. Well, if you see the positive side of it, there are always, and there is a positive side in COVID also. There is a positive side that there are opportunities for the acquisition of the units which cannot function in the present scenario. Well, they can be modified and we can have some better encashment of the same business. But obviously you need a different mind frame for that. Cost reduction measures will come. The labor cost or the various resource cost reduction techniques will come into picture and they will find a new sunshine. Construction regulations and construction methods will change. New business systems will come. There can be new methods and new businesses which will be coming in sanitization, PPEs. Hospital sector will be in of a different fashion. Health sector will take a different turn, and there will be a lot of different things. And in short, what I feel that today with the COVID in focus, we may define the basic needs differently and the wants differently, and that is going to change the overall scenario. If you see in India, what is the effect of it and what is the effect on the construction scenario? The situation is little different than the global scenario, because in India we adopt more labor intensive processes, little less of mechanization and more of descriptive and detailed methods of working. We will have to change. Skill development of the workers will be the basic theme. We will have to use resources and workers in an optimum fashion and in a trained fashion. So also the machines, equipments and the techniques of using them in the construction will be different. Maybe there will be different techniques which will be adopted. I mean the construction techniques which will be adopted for a long run, and which will in turn change the method of construction and method of planning also. You can see the labor which were there in the major cities have gone back. And once they come in, their labor wages are likely to go up. In addition, for the safety and the better future of human and mankind, the process and the approach of construction industry will be different to handle these resources and even give better health benefits to the workers. If you see, there is an investment decline. I just had a chance with the Financial Times review, and in Q3 of 2020 there is a reduction of 12 to 16% of investment in the construction industry. Now, on one side there is a reduction of investment in the construction industry, and contrarily the construction industry is in need of shift itself in a different manner. They need more funds, they need more resources, and this is a scenario which nobody had expected, and we will have to meet it with this. It is not only limited to sanitization, washing of hand, not only limited to the social distancing, and not only limited to adaptation of the mask. There can be embodied parameters in the new system which will not only take care of this, but there will be new financial constraints to be met with. The suppliers' time to supply the material and various equipments, machineries, their way of operation is going to change. Stocks of the construction industries which are recently going down immediately after the COVID. If you can just peep into the financials, there is a reduction of stocks from 30% to even 75% of the value of stocks. So this is again a big challenge, and we need to infuse more funds, and the methods of infusing funds are to be found out. Obviously, government is going to play a more important role. Maybe the contractor's billing cycle will have to be changed. Maybe whatever is done will have to be paid. Whatever the securities of contractors with the government will have to be honored in some different fashion, so that the liquidity is put into the business by contractors. If you are talking about what is the contribution from our side, I am with CIDC, and CIDC has taken a very positive step in India for better understanding of this scenario, to discuss this scenario, and to find out a way forward in the construction industry. The organizers of this India Construction Week, CIDC, under the brilliant leadership of Dr. Swaroop, have organized this online international conference and exhibition, which is going to take from the 1st to 5th of December 2020. And in that, the most important part is emerging technologies and construction construction infrastructure, which will be conveyed by Ashutosh Bharadwaj, and this is going to be a very, very important topic. We at Applecamy are trying to play and will be playing a very important and a key role in this particular event. In general also, Applecamy is playing a very important event in the construction industry, and we are there right from the stage of planning, at the level of execution, maintenance, and the lifetime maintenance and durability of the structure. We have various products, and these products are aiming on a different platform and giving a large benefit to the construction industry. And well, after COVID, maybe we will be playing a major role in reducing the quantity of the cement, quantity of the minerals which are used in the concrete. By that way, there will be cost reduction in the concrete itself. There can be reduction in the water utilized for the construction, during the construction, and the large amount of water which is used for the curing. There are some chemicals and techniques which can reduce this cost. There are some of the products which can help HVAC and reduce the energy consumption of the building. making green and sustainable construction and durable construction will be one of the prime most important parameters. We will be participating with our kit of innovative materials, products and techniques, and will try to reduce, along with the resources, the reduction in the labor cost also, which will be a direct an indirect effect on this. We are participating with CIDC, and I invite you all to be part of this India Construction Week and participate together. Let us work together to reboot India, to plan and position itself for a successful future. Thank you, and let us see, and I look forward to meet you all there in India Construction Week. Thank you. Hello friends, I am Vivek Naik, and today we are going to talk about India Construction Week after COVID. Specifically, we are talking about construction industry after the COVID scenario. Well, I don't mean that COVID is over, but yes, there is a transformation of the lifestyle because of the impact of COVID all over, and how we carry forward ourselves in the construction industry very successfully will be our aim. If you see the COVID scenario all over the world, and especially in the construction industry, many things have changed. Projects under planning have a different impact because of the economy, government rules, and preparation methods for the new projects. The projects which are already under the construction have got a severe impact because of the constraints of financial inflows, constraints of workers, skilled workers, and many resources. Some of the resources which were used in the construction industry have practically gone out. And the assets which are under the operation, we have to check up and verify today whether the planned resources and planned liquidity will come in the same fashion, or will it meet with again liquidity crisis. So this is a big scenario, and we have to tackle it in a different manner. If you see, there had been pandemics in the past also. You can take a case of Ebola, MERS, SARS, or even bird flu. But in my thinking process, they were local or regional. But the widespread impact of COVID-19 is phenomenal. It is having a severe impact today and will be having a lot of impact in the future also. The common issues can be workforce and the workforce leaving the territory. The cost of workforce obviously will be going up. Supply chain, yes, there will be delays, there will be disputes, there can be problems with the incoming material and the utilization pattern of it. Sales will decline and are declining. Cash flows obviously are getting affected. And the operational point of view, if you see, the reduced resilience and the key fundamentals are vanishing. There will be some new line of thought process coming as far as the operations are concerned. Take a case of even travels. Airline industry is hampered, people cannot reach. Buses are operating in a different fashion, so as the railways. So right from the communication and the commute of people to the project and construction industry is going to be different. Not all the regulations of regulating bodies, government regulations challenges their cash flows, IT finances, and even you see the legal proceedings. They are trying to have their interactions from home. So all this scenario is a very different and not expected at all. Well, if you see the positive side of it, there are always, and there is a positive side in COVID also. There is a positive side that there are opportunities for the acquisition of the units which cannot function in the present scenario. Well, they can be modified and we can have some better encashment of the same business. But obviously you need a different mind frame for that. Cost reduction measures will come. the labor cost or the various resource cost reduction techniques will come into picture, and they will find a new sunshine. Construction regulations and construction methods will change. New business systems will come. There can be new methods and new businesses which will be coming in sanitization, PPEs. Hospital sector will be in of a different fashion. Health sector will take a different turn, and there will be a lot of different things. And in short, what I feel that today with the COVID in focus, we may define the basic needs differently and the wants differently, and that is going to change the overall scenario. If you see in India, what is the effect of it and what is the effect on the construction scenario? The situation is little different than the global scenario, because in India we adopt more labor intensive processes, little less of mechanization and more of descriptive and detailed methods of working. We will have to change. Skill development of the workers will be the basic theme. We will have to use resources and workers in an optimum fashion and in a trained fashion. So also the machines, equipments and the techniques of using them in the construction will be different. Maybe there will be different techniques which will be adopted. The construction techniques which will be adopted for a long run, and which will in turn change the method of construction and method of planning also. You can see the labor which were there in the major cities have gone back, and once they come in, their labor wages are likely to go up. In addition, for the safety and the better future of human and mankind, the process and the approach of construction industry will be different to handle these resources and even give better health benefits to the workers. If you see, there is an investment decline. I just had a chance with the Financial Times review, and in Q3 of 2020 there is a reduction of 12 to 16% of investment in the construction industry. Now, on one side there is a reduction of investment in the construction industry, and contrarily the construction industry is in need of shift itself in a different manner. They need more funds, they need more resources, and this is a scenario which nobody had expected, and we will have to meet it with this. It is not only limited to sanitization, washing of hand, not only limited to the social distancing, and not only limited to adaptation of the mask. There can be embodied parameters in the new system which will not only take care of this, but there will be new financial constraints to be met with. The suppliers' time to supply the material and various equipments, machineries, their way of operation is going to change. Stocks of the construction industries which are recently going down immediately after the COVID. If you can just peep into the financials, there is a reduction of stocks from 30% to even 75% of the value of stocks. So this is again a big challenge, and we need to infuse more funds, and the methods of infusing funds are to be found out. Obviously, government is going to play a more important role. Maybe the contractor's billing cycle will have to be changed. Maybe whatever is done will have to be paid. Whatever the securities of contractors with the government will have to be honored in some different fashion, so that the liquidity is put into the business by contractors. If you are talking about what is the contribution from our side, I am with CIDC, and CIDC has taken a very positive step in India for better understanding of this scenario, to discuss this scenario and to find out a way forward in the construction industry. The organizers of this India Construction Week, CIDC, under the brilliant leadership of Dr. Swaroop, have organized this online international conference and exhibition, which is going to take from the 1st to 5th of December 2020. And in that, the most important part is emerging technologies and construction construction infrastructure, which will be conveyed by Ashutosh Bharadwaj, and this is going to be a very, very important topic. We at Apple Chemie are trying to play and will be playing a very important and a key role in this particular event. In general also, Apple Chemie is playing a very important event in the construction industry, and we are there right from the stage of planning, at the level of execution, maintenance, and the lifetime maintenance and durability of the structure. We have various products, and these products are aiming on a different platform and giving a large benefit to the construction industry. And well, after COVID, maybe we will be playing a major role in reducing the quantity of the cement, quantity of the minerals which are used in the concrete. By that way, there will be cost reduction in the concrete itself. There can be reduction in the water utilized for the construction, during the construction, and the large amount of water which is used for the curing. There are some chemicals and techniques which can reduce this cost. There are some of the products which can help HVAC and reduce the energy conservation, energy consumption of the building. Making green and sustainable construction and durable construction will be one of the prime most important parameters. We will be participating with our kit of innovative materials, products and techniques, and will try to reduce, along with the resources, the reduction in the labor cost also, which will be a direct an indirect effect on this. We are participating with CIDC, and I invite you all to be part of this India Construction Week and participate together. Let us work together to reboot India, to plan and position itself for a successful future. Thank you, and let us see, and I look forward to meet you all there in India Construction Week. Thank you.
Thank you, CIDC, for giving us this opportunity to present our innovations on this platform. I'd like to introduce myself. My name is Sharan Grover, and I'm the product manager for light duty power tools in India. Hilti has a age-old tradition of innovation and supporting technologies which bring productivity to a construction job site. And in this day and age, productivity has become the need of the hour. We have good enough experience of knowing some of the pain points that sites face, and we have technologies to address them. So today, let us look at how cordless tools are able to bring productivity to your job site. Great. So let's start by looking at some of the top concerns of a construction project. The first and foremost and the main one is delivering the project on time and within budget, more importantly. So this is the end goal of all project managers, and this is what everyone strives for. However, there come some challenges like unexpected problems at site, maybe some wrong positioning of anchor, wrong positioning of structure. Sometimes there is rebar reinforcement. Then we also have to worry about workmanship quality. For that, we have to continuously supervise or do pull-out tests as an example to check the correct installation quality of an anchor. And last, we are very worried about the workforce competence, whether we have good experienced labor at site, how will they handle the products, how will they handle tools. Thank you, CIDC, for giving us this all the structures properly. So point number B, C and D together lead and contribute significantly to A. And so the most important point for the project manager today is to deliver a project on time and within budget. For this, productivity becomes very important. Productivity can be defined in two different ways. One can be that you do a task with less labor, or the other could be that you do the same task faster. Choice is ours. So if I take an example of a particular job which takes 6 people and 10 days to complete, if I were to bring in 2 times productivity to that job site, what that would mean is if time is not important, then I'll finish that job with less manpower or 3 people. However, if time is important, then I keep the same manpower, save time, and finish the job in half the time, 5 days. So this is how productivity can be defined: more speed, more output with less manpower, resulting in saving costs and boosting your profitability. Technology or the adoption of technology is one of the strongest levers to make us more productive. And at Hilti, we have different technologies which can help you do so. Let us first look at the construction industry and the growth of productivity over the years. Unfortunately, if you see this graph, you see that the construction industry has lagged years since 95 to even 2014. It's remained more or less flat. The productivity has not improved. Whereas if we take a benchmark of the total economy or even the manufacturing industry, you see how steep that slope has been. In the early 2000s, they have reached a certain level of productivity and they're maintaining it. But our construction industry remains slow in this regard. However, with RERA coming in, it becomes very important to be more productive now. And the top 2 factors to improve productivity are reducing the non-productive activities on the job site or use of technology. If we adopt these two, we will be highly productive. If we do not adopt these two, then our hidden cost factor, which we see here, keeps going up. Most of the time, all of us are focused on the visible cost, which is the material purchase costs, and thereby, if we do not adopt these 2 factors to improve productivity, our hidden costs will definitely increase. Can address the 2 key drivers of productivity. They will help improving on-site execution and reduce unnecessary input costs. Let's have a look on the left side of the screen and look at a few pictures. Labor is taking. You can look at cord breakages. You can look at power cuts. Imagine the setup time, looking for an electrician, laying the cables, getting work permits, setting up boards. How are these really productive activities? It really takes up a lot of our time. And on the right side, look at these other costs. Look at those meters and meters of cables running for which we pay money and don't keep track of them. Look at the DG set, which is required in remote locations to power the job site. And our tools. We keep repairing the tools without looking at how much we've actually invested in the repair. And one level arises when the repair cost of the tool has exceeded the purchase cost itself, and still we are repairing. Why don't we eliminate all these unnecessary input costs? And cordless is the way to do so. So the top 4 reasons to go cordless will tell you why. Cordless tools are simply able to bring a much better productivity. Imagine you will not need to wait for any setup time. You will not need to wait to pull cords, lay electricity. If power goes off, you can still work. And with technology such as impact wrenches, we are also able to bring up to 2 times productivity to many applications. Imagine working at a height. You need to pull the cable to the height, you need to take the tool to the height, and then you need to manage everything. So that also becomes much easier with cordless tools. Second point is it reduces the overheads. How much do we currently spend on cables? Have we thought about it? Imagine if the cost which you allocate to cables, boards, and plugs can be translated to a much more productive investment which remains with you for 3 to 4 years. That's the advantage of a cordless tool. You save on these hidden costs, make that investment, and become more productive. Safety is a very important factor as a third point. First, you can cut out the hazards of electrical shocks. Second, you do not have loose cables and boards. Third, it's much easier working on heights. And another point I'd like to make here is that our cordless tools come with very different features which add to worker safety. Let me give you an example. AVR, that is active vibration reduction, reduces the vibration that a worker feels. DRS or dust removal system. It's an onboard vacuum cleaner as you see in the picture, and it prevents the worker from getting drilling dust. ATC as another example. Imagine if your drill machine gets stuck in rebar, it will turn. So many of these tools have these features and they promote worker safety. Lastly, our cordless tools come with a unique 2-year no-cost service proposition, which means that there will be zero repair cost for 2 years from the date of invoicing. This is much more than simply manufacturing warranty. It's a zero repair cost for 2 years, and we also have a repair cap on the third year. That controls your total cost of ownership for your tools. Despite having some positives, there are some myths or beliefs about cordless tools which are not really true. The first myth is that cordless tools have less power than corded tools. This is the first myth that we need to debunk and bust. It has been tested and proven that cordless tools in a particular class will give the same power as that of an equivalent corded tool. If I take an example, if we have a 16 millimeter range drilling machine corded, it will give the same output as a cordless. There is no less output. There are electronics inside which ensure consistent power and constant output. Another myth is that cordless tools do not have enough battery life. The batteries will keep getting discharged. Maybe this was true many years ago, but lithium ion technology has evolved to a large extent and we are able to pack in much more energy into a smaller battery. Hilti batteries are of three types: a compact one for light applications, a power one for medium applications, and an ultimate one for heavier applications. Depending upon what your need is, we can make a kit for you which will make it last your workday. Another myth is that cordless tools are not robust enough and hence will have some high service costs. To debunk that myth, we can say Hilti cordless are robust and designed for construction industry. There are features such as overload protection. Many of our cordless tools are brushless, and this leads to a much lower repair frequency and a much higher life. Additionally, we still have the 2-year no cost to protect you in case of any standard wear and tear. So the repair cost is not really a problem. The last one is cordless tools. I mean, the productivity will be hampered because my batteries will take too long to charge. Let's say that's another belief. Let me debunk that too. We have a range of batteries with different charging time. We have a range of chargers, a fast charger and a universal charger. If I take the example of our most powerful battery, which is the B22/8 or the ultimate class battery, that charges within 50 minutes using Hilti fast charging technology. So just charge during a lunch break and you're ready to go. So these were some of the myths about cordless tools that we have debunked. Now let us look at some of our cordless tools in action and what all they are capable of doing. So we saw that we can make almost all our applications cordless, and using cordless brings up to 2 times productivity and for sure reduces your cost of tool ownership. Let's take an example of few of the applications which we can make cordless, ranging from wooden formwork to my one formwork to base plate anchoring, rack fixing, interior finishing when we talk about the drywall application, MEP supports, the structural steel fabrication and deck sheeting application, as well as rebarring. These are some of the examples for which we have a solution, and there are many more tools also which you can use for different solutions. So this is the power of cordless. Productivity is the need of the hour, and it's time that we kick the cord, adopt new technologies, and work towards being productive and cost efficient. So with that, I'd like to thank you for your time. If there are any more details you would need from Hilti, you can feel free to contact me at my phone number or at the email address mentioned. Thank you so much again.
I am Harshvardhan Verma and I am the product manager for Diamond Tools and Vacuum for Hilti India. I would like to thank ICW for giving us this opportunity to be a part of this platform. Regarding emerging technologies in construction and infrastructure, one of the area where construction is making a leap ahead is dust-free technologies. I will be taking you through the emerging dustless technologies in construction.
Hi, we are going to discuss dustless technologies in construction. So these are the content that we are going to cover. First, key challenges in construction industry. Second, source of dust and its effect. Third, types of solution for dust. Then what is DRS? Dust removal system. Then the dustless diamond grinding and then the role of LT. So let's start with the challenges in the construction industry. So what are the key challenges that you face in construction industry? We have divided it into four main buckets. First one is time pressure, then second quality of work done, then the third is the working condition, and of course the fourth one and the most important work is the health of workers. You can think of which challenges are your company facing. So let's start with the background to dust in construction industry. So if you see the sources of dust, there are two main sources of dust on a job site. First, the dust that is being generated during the work. Second, the dust that circulates on the job site. So what are the sources of these dust? What are the types of dust that we see on these job sites? So it depends on the base material. So there are five main buckets. First one is concrete, then stone, then brick, then plaster wood, and then the wood. Depending on the base material, it depends what are the harmful contents of the dust. Now, when we know the types of dust, these types of dust have various sizes. So it can vary from very small size to very small size, as in, for example, 50 micron to maybe very less than zero point 0.1 micron. Let's see what are the harmful effects of dust on construction industry. So there are four main harmful effects. The first one is productivity loss, then reduction in tool life, then the health hazard, and of course the most important one, hazard to the environment. So let's delve deeper into each one of them. Let's start with the health hazard. So on every job site, there are many works that we do, like drilling, chiseling, slitting, sanding, and grinding. And many of these base material, they contain hazardous material. For example, silica or quartz in concrete, maybe mortar, bricks, and blocks. Then wood dust in hardwood, softwood, MDF, and chipboard. And depending on these base material, there are many harmful effects on our health. For example, cancer, lung disease, or maybe asthma to people who are overexposed to these conditions. So basis on the exposure to these base material, there are two main effects on the health. First is short-term effect and then the long-term effect. In short-term effect, if you see, there might be visibility reduction in visibility condition, maybe concentration, red and increased risk to injuries. If you see the long-term consequences, there are respiratory diseases, silicosis. Now the point to be noted is the impact is not just to the end user but to the everyone else who is working on the job site. Now we have seen the content of the dust, the sizes, the various sizes of the dust. So if you talk about the 15 micrometer, it stays in the air for maybe 10 seconds. But for a dust particle which is smaller than zero point 0.1 micron, it stays in the air for 12 days. So it very much affects for everyone else also on the job site. And these harmful contents can cause lung cancer, silicosis, COPD, and diseases like. Now let's talk about the productivity part. So if you see the productivity of any other sector compared to or maybe vis-a-vis to construction industry, the productivity of all other industry like manufacturing industry or maybe the total economy is way more than the construction industry, and it has evolved over the years. If you see a data from 1995 to 2014, the construction industry, the productivity has not increased much if you compare it with manufacturing industry or total economy. So what are the main drivers? So biggest opportunity lies where? So to increase the productivity, there are two main opportunities. First one is on-site execution and second with the user. So let's see how the dust affects productivity on a job site. First one is the direct correlation. The workers, they cannot work for longer hours. Also, the other person working in the vicinity also cannot work for longer hours. And then the reduced visibility. It slows down the work and increase the chances of accident. The second or maybe the indirect factor is it is one of the biggest factor for tool damage. The dust enters the tools in the vicinity. The tools has various moving parts and wear out parts. So now when the dust enters the tools, it directly wear out those parts and reduce its life and maybe cause the breakdown as well. So with the breakdown, the cost also increases and also it reduces the productivity as the tool stops working on a job site. So now when we have seen what are the ill effects of dust in a construction industry, let's see what are the common practices nowadays which is being followed on Indian job sites to counter the dust. We use air cleaners to remove the dust. We use dust suppression methods to suppress the dust. Then when the dust is there, the third and the most important method that is being used is the protection, which is the PPE. The people use dust masks, they use eye protection gears, etc. Let's see how technology can help better to curb down dust at source. So there are two main buckets. The first one is use of dust removal system from source itself, and the second is use of alternative technology that does not involve dust at all. The first method is wherein the you are producing the dust, you are removing then and there at the source. The second method, for example, we change the technology. I'll take an example. Suppose for facade installation, you install the anchor and for that you have to drill a hole, so, which produces dust. Now you can change that technology altogether and use a casting challenge which is embedded during the casting of the concrete and it will not involve any dust. So this is an alternative technology which can help reduce the dust production. Today we'll focus mainly on the first method, which is use of DRS system, which is dust removal. The first one is built-in dust removal. It removes the dust at source. It comes along with a vacuum cleaner which is being attached to the tool itself. The second one is use of an external vacuum cleaner to be used with different tools like concrete grinding, concrete cutting, breaking, or maybe drilling application. All these tools can be used with one single vacuum cleaner. And the third method is use of alternative technology that we have discussed. This is how the dust removal system looks. It uses a universal vacuum cleaner which can be used along with many of the tools like the drilling machine, the breaker, a concrete grinder, or maybe a concrete cutter. And along with that, we have to use specialized insert designed to suck the dust. For example, hollow drill bits. So let's delve deeper into dustless diamond grinding. We see a lot of concrete grinding application on many job sites. For example, in new buildings, we use it for removing the burrs, the imperfection on the joints. We use this to prepare the smooth surface for painting and coating. Now, for a building wherein we are doing renovation, we use it for removing the coatings or maybe the paints. On a civil job site, we use it on bridge and metros, for example, for bridge pier cap grinding, for crash barrier grinding, for viaduct grinding, etc. Now, this is an application which involves a lot of dust and it is very exhausting as well. So let us understand this with the help of a video. Why we should use the vacuum cleaner. Let us summarize that. The first and the foremost reason for using a vacuum cleaner is health and safety concern. We have discussed this in detail. Second is it is a mandate also in some countries and for some government institution. So there is a mandate in some countries wherein you have to reduce the dust level below a certain limit. Third, it is a productivity booster. Fourth, it makes the work very comfortable. And fifth, it increases the lifetime of the tool. So what is the efficiency of dust removal system? If you use a DRS or dust removal system, it reduces the dust that is being inhaled by around 99%. So let's see what solution Hilti has for concrete grinding. For dedicated concrete wall grinding, Hilti has DGH 130 system with VC20. For floor grinding system, Hilti has DG 150 with. All in all, I can say the industry awareness is rising everywhere. There are high investment to reduce the injuries and accidents. There are stricter regulations, but it is not just about the compliance. There is heightened safety culture in many companies, and many of the companies they identify that it is an investment rather than a cost. All in all, these technologies and Hilti can help you achieve substantial productivity gains and make your job site safer. So, four main challenges of the construction industry being addressed with these technologies. The first one is time pressure. With effective productivity gain, the time pressure will be relieved. Second, when there is no dust, there will be no question of poor installation quality. The working condition. With dustless job site, the working condition is definitely going to increase. And last but not the least, the health of the workers. With reduced dust, of course, the health of our workers will improve. We are here to support you. If you want to learn more, visit www.hilti.in or you can post your questions on ask.hilti.in. Thank you.
For hosting us today. Really excited to be talking to you. For hosting us today.
Namaskar. Welcome to India Construction Week 2020, an online.
Hello friends. Hello friends.
Thank you, CIDC.
I am Harshvardhan Verma and I am the product manager for Diamond Tools and Vacuum for Hilti India.
For hosting us today. Really excited to be talking to you. And we have been working in the area of 3D printing for almost 3.5 years now. And we are based out of Chennai in India, southern India. And we have been building an end-to-end solution to cater to the affordable housing needs, especially of India and also
Hosting us today. Really excited.
So we started, three of us, a few years back, building small 3D printing solutions, but we felt that the greatest opportunity that where 3D printing could really contribute was in the construction space, and that's how we started developing the solution. And I'll probably start speaking about why India really requires something like 3D printing to solve its affordable housing needs. So if you have seen, construction all across the globe, and especially in India, nothing has really changed for the past 50, 60 years. In India, especially precast and other construction technologies are spoken as if they are new technologies, whereas precast really has existed in this country for almost 60 years and has been not able to penetrate into the construction industry in general, and especially the rural market where majority of India's population resides. India requires about 100 million houses by 2030, and the government is planning to build about 20 million houses by 2022. If we are to solve this problem, it is going to be solved only through technology, and that is where we want to come in. We want to provide a complete shift in the way affordable housing is viewed, and we want to enable that for a majority of India's population as quickly as possible using 3D printing with a sustainable and speedy solution. So that's what we are working towards. And this is, in essence, what ails the construction industry. So if we have looked at the productivity charts, especially in the manufacturing and construction space, for the last 50 years, nothing has, in the construction space especially, nothing has really changed. That's because of the lack of automation that has been there in the construction space versus manufacturing, which has quickly adopted CNC machines, robotics, database technologies, and moved forward with its productivity. Whereas construction industry has been sort of lacking with that, and especially in a labor surplus market like India, construction has relied on a surplus of skilled laborers to execute its projects, and this has not been able to deliver the kind of solutions that the affordable market requires. I mean, there is capital, there is land available, but this is one of the very rare industries which is constrained by a supply side problem. So this is what we are intending to tackle with automation. So I would like to just show you a brief video to just highlight what the problem of housing in India really is. Um, I'm not sure if you're able to hear my audio.
We are not, but
Yeah.
maybe you can sort of voice
Just,
over or talk
just
us
give
through
me a
this.
moment. Yeah, just give me a moment. I think
you can try to, if you try to click on your photo, I believe
Yeah.
there's a button that will let you share your computer audio.
Yeah,
மழை வந்தாதான் இருக்கவே முடியல ரொம்ப
I hope
டேமேஜ்
you are
இருக்கு
able to
Yes,
hear it now.
yes.
ரொம்ப ஆடல் பட வேண்டியது
Yeah.
அப்போ எப்படி
இதா இது போல பாய் எல்லாம் போட்டு கொஞ்சம் ரொம்ப கஷ்டமா
So the condition of, I mean, especially the urban
எல்லாம் வந்து எங்கன்னா ஓட வேண்டியதுதான் மேல
and also the rural poor in India is extremely bad. The kind of housing that they live in, they are absolutely exposed to the elements, and during natural disasters, they are the ones who suffer the most.
இப்போதைக்கு என்னால் வீடு வாங்க முடியல लोन के लिए सोचा बाकी तो कुछ सोच नहीं पा रहा हूँ लेकिन लोन भी इतना अमाउंट होता है तो लेना बहुत भारी होगा सपना है लेकिन सपना पूरा नहीं कर पाता हूँ
अभी इतना है अभी हम लोग कितना 100-200 रुपया कमाते हैं घर में उसमें तो 50 रुपये चाय का पकड़ लो 100 रुपया खिचड़ी पिचड़ी सबको पका कर 50 रुपये चाय पचाए सब बच्चे लोग को हो जाता है खर्चा अभी हम लोग इतना 2-3 लाख रुपया कोई मांगेंगे तो हम लोग कहाँ से ला के देंगे ऐसा है इसलिए हम लोग इधर रहते हैं
So the housing problem in India is multifaceted. There is an issue of financing, which the government has tried to address. So, for example, for the housing mission that they currently have, they were planned to build about 20 million houses by 2022. Of that, about 6 million were grounded, in the sense financing was arranged, the land was arranged, but only about 0.8 million was actually built. So even after the financing solution was, the financing problem was addressed, and even after land being available, all the legal aspects being taken care of, the execution is absolutely not to the level where 20 million houses can be delivered. So that is where we feel technology-based solutions can really make a difference. And we need a technology that is really portable, that can travel from location to location, that can enable construction not just in the urban centers, but in the rural areas where almost 60 to 65% of Indian population really resides. So that is why we are developing a solution that is independent of supply chains, that can travel to rural areas and deliver urban quality construction in rural areas, not just any kind of construction. So this is the vision with which we are working to create a tangible improvement in the life of individuals with a shelter. And as I mentioned, India requires this solution and the world requires this solution. Frankly, I was just, in the speakers roundtable, I had a wonderful conversation with people who are solving the housing problem in Africa as well. And Africa is estimated to require almost 500 million houses by 2030. So this is a global problem, and we are working towards that. So before I speak with respect to what we are building, I think I would just like to speak about the partnership with Habitat for Humanity as well. Habitat has been doing a lot of work in India and across the globe in 70 countries with respect to housing. And with the Shelter Tech Accelerator, what we have actually received is an opportunity to really understand the housing problems, not only from what we have been able to gather, which is really minimal. It is constrained by geography, it's constrained by how many people we are able to speak to. And Habitat has far more experience. And through the Shelter Tech Accelerator, we have been really able to understand what are the various problems that exist in housing, apart from just the construction aspect. And also, how do we do that in a sustainable manner? And how do we do that for different markets? So that is something that we have been working towards.
That is wonderful, Aditya. I think that's a great large goal. And what is the technology? Can you walk us through what you have developed by way of your technology and solutions towards this?
Sure. Yeah. So maybe before I get into the technology, I would just like to speak about the kind of impact that we are envisioning with our technology coming into the market. And these are two photographs that are very commonly used to emphasize disruption. And yet we sort of fail to understand what disruption could really be in any industry. So this is New York in the early 1890s, and this is New York 10 years later, after the advent of automobiles. And you can see the sea change that was driven within that city by Ford releasing the Model T. And this is the kind of innovation, this is the kind of disruption that we would like to bring with construction 3D printing. And it is really possible because I mean, this is one industry that has not really changed for almost 50 to 60 years at all, especially in a country like India. It has remained static for a very long period of time. So it would be very difficult for people to imagine what automation and construction can do, but it can drive productivity up really a lot. And we have a team of 20 very talented engineers who are working across disciplines, mechanical engineering, civil engineering, software, electronics, and also construction strategy. And the company, as I said, was started by three of us about 3.5 years back. So what we are actually building is a mass scale automation of construction, which is customizable. That is the only thing that you have to change to really print a different design is the BIM file or the digital file. So earlier you had to, manufacture new formwork, have new plans for designs, but here nothing is required. You just modify the BIM file, update it to a 3D printer, and we are ready to go ahead. We are trying to reduce the quantity of materials that we use to make our solution much more sustainable. And in terms of time, we are delivering an order of magnitude increase. It's not even a percentage increase. And we are working on reducing the cost with scale as well. That is, when we scale up, the cost will continue to reduce. And the technology that we have developed is really end-to-end, in the sense we have developed the 3D printer, the material, the software, and other solutions that are required for this. So I'll just probably go through the problems that we can really tackle. With respect to affordability, there is a problem of transparency and affordability in the market, even within the same geography. In especially a country like India, there is no transparent pricing for the same structure. And also affordability becomes a problem when things are tied to many supply chains. So this is something that we are trying to change. We want to reduce the cost of construction considerably to 40%. Sustainability is an aspect that we are working on to reduce the amount of material that we use with construction. Productivity, as I mentioned, is the lowest in the construction space, and Indian labor productivity is the lowest among almost all major economies. So that is something that we are working on. And this is something that we are extremely passionate about, to deliver urban quality construction in rural areas. We want to ensure that there is no distinction between a rural house and an urban house. And anyone who has traveled into rural India will know that, the cities are constructed in a, I won't say a very good way, but in a particular way. And the rural houses are just put together. So in that sense, that is a major problem in this country. And speed, as I mentioned, speed is becoming a problem with respect to government's affordable housing program and affordable housing in general. So I'd like to change that. So these are 3D printers that we have built. That is currently hosted in Chennai, India. And these are production systems. We are manufacturing on-site systems and also off-site systems. So what is displayed here is an off-site 3D printer, which is hosted within a factory environment. And currently what we are doing is we 3D print modules and then they are assembled on site. We went ahead with this method in the beginning because the supply chains are easier to sort of handle when the 3D printer is hosted within a factory. We are moving towards on-site printing. In fact, our next project is going to be done on-site. And we have been successful in making our 3D printer supply chain independent. So in that sense, we are able to sort of transport our printer to faraway locations and start 3D printing immediately. And one of the key areas that we can tackle immediately is disaster relief. So that is something that we have a large project on. So I'd just like to take you through a video as well of our process. So as you can see, with 3D printing, we can create any sort of form without formwork, without any support material. And hence we are really opening a new paradigm of designs to architects and designers. When designs are constrained by formwork, especially in a market like India, it becomes unviable. One of the key aspects of 3D printing that we have been working on is to make it affordable. We have been trying to make the material as similar to normal construction concrete in terms of cost as possible, and we have been extremely successful. So we had to redesign the pumping system, we had to redesign the material delivery system to sort of achieve it, and we have been able to do that. Several of our patents are actually on the material delivery system as well. So our solution, as I mentioned, includes the 3D printer, which is a patent pending, and a material delivery system, which we have patented. And we have a proprietary raw material. As you might know, construction 3D printing cannot use normal concrete because the concrete has to take its own weight while being printed. So we have developed a proprietary raw material that can be used for this. We are also developing non-concrete materials that we are planning to use. And we have developed a software which can really enable BIM-led construction. That is, we can take a BIM file, we can clean it, and we can directly use it with our software. I have a demo of our software coming up as well. And one thing that we are really working on is design for additive manufacturing. 3D printing offers so many advantages while building something that it would be a shame if we don't take advantage of that process. For example, in the video that you just saw, the modules that we were printing were not 100% solid. We could achieve the same level of strength with 45% infill or 50% material that otherwise would be, 100% while using conventional construction. So to take advantage of additive manufacturing or 3D printing, some modifications on the design have to be done. We are trying to do it by providing customers that experience, but moving forward, we would like to automate that process as well. So that is something that we are working towards. So this is the software solution that we have completely developed from scratch. Everything including the slicing, the viewing, editing designs, the cleaning of BIM models that can really enable architects to work with the software much easier. So these are aspects that we have done on the back end. The software can also completely track where the 3D printer is, how it is printing, what amount of material is left. So all the feedback mechanisms are sort of embedded into the software itself, and there is very good data logging and data analytical capability built into the 3D printer. So the 3D printer can correct itself in the middle if there are errors being generated during the printing process. Let's say because of any abnormalities in the material mix design or anything of that sort.
And this was completely done in-house by your team?
Yeah, so this software was completely built in-house by the team, and we are sort of improving upon it moving forward. We want to enable customers to have a direct BIM viewing capability, BIM interface capability. So this was done completely by the team, yes. Yes, ma'am. So that has been the technical journey of the team.
Yeah. So, we have 10 more minutes. So, do we want to jump ahead into the current work you're doing? Because,
Sure, sure.
there was work in the past. Yeah. And, based on time, we can come back to this.
Sure, sure. So I'll quickly maybe just say that this was one of the 3D printed structures that we did in the past. So we had a conference with the Ministry of Housing in India, who are trying to accelerate us through their procedures so that we can have regulatory approvals quickly. I'll just skip that particular video. So we are currently finishing a 3D printed house in India. We are doing this in partnership with Habitat for Humanity. So this would be India's first 3D printed house, but also this would be a unique structure with several unique shapes and unique features. And this is sort of, we are developing a template for making affordable housing possible in the country. So this is a 600 square feet house. 400 to 600 square feet is what is usually used within the affordable housing space. So we have a short message from the Vice President of Habitat.
Hi everyone, it's Patrick Kelly from the Terwilliger Center for Innovation and Shelter at Habitat for Humanity. We're passionate here about market-based scalable solutions for affordable housing. With almost 2 billion people in substandard shelter, we need the creativity and the innovation of startups and entrepreneurs. So we're very excited about Tavasta, an alumni of our Shelter Tech Accelerator, recipient of one of our catalytic grants, and are thrilled about the 3D printing technology and them bringing that to the issue of housing. We think Tavasta is positioned to build for $1 billion with their technology.
So thank you for the support that Habitat has been providing us. I'll just show you a short rendering of the house that is being built and take you through the actual process of the house that is being built. So this would be a unique structure. We wanted to showcase the uniqueness that could be bought in using 3D printing. That is why we have gone for a few irregular shapes. But at the same time, we have retained several aspects that would be standard across affordable houses. And we are building upon this to get our regulatory approvals for starting larger projects, much larger projects in the country. Yeah. Just to take you through a video of the construction process. So this, as I mentioned, is a off-site 3D printing project. That is, we have built the modules within our factory environment and we'll be assembling it. Our next project is on-site. Off-site 3D printing has got its advantages because in Indian urban landscape and also in Indian rural scenarios, not every site is really accessible with a 3D printer. So in that sense, off-site 3D printing would have a major role to play going forward as well, because we see that to be one of the most viable technologies, especially when large-scale production is involved. If 50, 60, 100 structures are getting printed at a time, off-site 3D printing would be the method to go. So there has been disruptions with respect to our construction process due to COVID. Few people have tested positive and we have not been able to finish it. But we are quickly planning to finish it within the next 5 to 6 days. The modules will be actually locked together using a dry joining process. So it's a very simple procedure. All the provisions for joining the modules together have been provided. So moving forward, we are integrating finishing processes into our 3D printing as well. So here finishing is done conventionally, in the sense plastering, etc. But moving forward, the printer itself would be able to take care of that. So that would be a huge added advantage because that's a very skill-intensive, costly process. So by reducing that, we are planning to reduce the cost of construction quite a bit as well. Yeah.
Okay, so what you mentioned about other sort of printers, right? The on-site printers and others that you're looking at. So can you walk us through what else are you planning to do going in the future?
Right. So moving into the future, we have a new project coming up, which would be a much larger structure, and we are planning to do it on site. This would be another project in Chennai as well. So that would be done using on-site printing. But one of the things that we are really convinced about is in a country like India, you require a combination of both on-site printing and off-site printing, and you require a few integrations along with 3D printing to really make affordable housing viable. That is, we require finishing processes to be integrated into the 3D printing process, so that while the module moves out of the 3D printer, or when the 3D printer moves out of the construction site, it's not just the superstructure that is built, but all the other elements that are required to make a house livable are also done along with the 3D printing process. That is something that we are convinced about. And offsite 3D printing has a major role in construction going forward, because there are certain projects that become very viable using offsite 3D printing. There are certain construction sites which would be very expensive for on-site 3D printing. Not all sites in India are plain land where printers can be easily assembled. So there is a niche for both. We are developing both these solutions. So we'll be moving towards G+3 structures very soon, and then we would work towards building larger structures. Our next project is a G+1 project. And our aim is to get towards a point where we can build an affordable house in 3 days. I'm talking about several other aspects other than the superstructure, and a toilet module in 6 hours. And as I mentioned, integrating finishing processes into construction 3D printing is something that we are very passionate about, and that's something that we will work towards. And we have built a very robust ecosystem in India with respect to construction 3D printing. We work with all the major academic institutions in the country, the top 3 academic institutions in the country, with respect to getting our process standardized for various regions in the country, and also for deploying our solutions. We have already tied up with cement companies and also major construction companies. So that is something that we have already achieved. So in terms of scaling up, one of the things, as I mentioned, that we are very passionate about is not just scaling up for urban and rural markets, but also for the rural market, which is very important for us moving forward. And to make construction affordable and transparent is something that is very important for us. Transparent in the sense pricing is extremely opaque in the Indian construction space, even within the same geography for the same kind of structure, and making it affordable with integrated finishing. And we have certain collaborators who would be able to sort of manage several aspects of construction that we are not intending to get into. Construction, as you're all aware, is not just about building a structure. There are legal aspects to construction. There are financial aspects to construction. There are, permissions, etc. So we have tied up with a few partners who would enable us to scale rapidly, who are already in the construction space, who have that scale. So this is where we are right now, and very exciting times ahead.
That's really wonderful. So in your past projects beyond that structure, you also had some toilet modules and others that were built, right? I mean, we didn't have time to cover those aspects. So that's really wonderful. And anything else on, going beyond India for opportunities outside? And anything on, how are you different from maybe, others that are out there, right? I mean, there are probably other people offering such solutions also. Any thoughts on those?
Yeah. So on the toilet module, so toilets in India have been a great there has been a massive change with respect to toilet availability in India, and there has been a massive push from the government. And we work with one of India's largest construction companies to enable toilet 3D printing for their CSR mission, and that project is slated to scale up quite soon. And on expanding beyond India, we do have a couple of markets that we are looking at. Southeast Asia is one. Africa is certainly somewhere where we see potential, but we would like to partner with other companies to go into that market, because that's not really somewhere where we have capabilities. And also Middle East is something that we already are looking at, and where we have a few proposals with respect to projects, and mostly around the affordable housing space. Africa and Southeast Asia have massive requirements, so that is something that we are working towards. On the differences, one of the things that we learn the hard way is in India, if we have to stay relevant, you have to focus on affordability and reduce cost. Without cost, you're a non-player in this country. So we have been able to design everything, the 3D printer, material delivery system, the material itself, and our entire methodology of working around cost. So that is something that would give us an advantage while dealing with emerging markets. Our material is affordable, our 3D printers are affordable, and our process in general have been designed keeping the cost constraints in mind with respect to supply chain, what is available for assembling a structure. If a 3D printer has to go onto the site and then 3D print, is it viable cost-wise? So these are things that we have thought through, and that I would say is a key advantage that we have. And also our vision of integrating all the other processes. We are not just looking at 3D printing the superstructure, looking at few other processes to sort of enable affordable housing. A house will be delivered and not just a structure. So that is something that we are really passionate about. So I would.
Good morning, good evening, good afternoon to all of you, whoever is present from different parts of the world. At the outset, I would like to thank the organizers for giving me this opportunity to give this talk on emerging technology in construction as CSR SCRC perspective for the International Construction Week 2020. So before I start the technical presentation, I would like to let me just get into the laser pointer. Okay, so this is our laboratory. So we have got four thrust areas. One is structural health monitoring and life extension, and then disaster mitigation, advanced materials, and spatial and multifunctional structures. And these thrust areas, for that there are actually 10 number of laboratories which are listed at the bottom. Advanced materials laboratory, advanced concrete testing, and evaluation laboratory, and so on and so forth. And we cater to technology development, consultancy, sponsored research, as well as futuristic R&D, which is related to different of India initiatives, and which also supports the industry and society. So these are some of the laboratories, unique laboratories in the country that we have. One is we have a wind tunnel facility, which is the largest in the country. It's a boundary layer wind tunnel facility where we can evaluate all the wind loading, which structure, including the aeroelastic effect. This can be subjected to. We have a shake table. Again, right now this is the largest shake table, which is 4 by 4 meter triaxial shake table that we have here. We also have a fatigue and fracture laboratory, which is an extensive number of different sizes of actuators we have, from 50 kilonewton to 2000 kilonewton. And we also have a tower testing and research center where full-scale towers, transmission towers, are tested. And similarly, other laboratories which we have, you can see that there. Now, coming to the scenario in construction sector, as we all know, that the civil and infrastructure sector in India is poised to be the world's third largest construction market by 2025. Government of India has already promised an investment of allocated an investment of 50 trillion rupees by 2022 to realize the sustainable development that is needed. And one report tells that, which is a think tank of India, it tells us that the world-class infrastructure if we can develop, that leads to 9 to 10% growth of the economy. So therefore, there is a large scope which exists to develop technologies which will meet the market expectations and also to be a global competitor. This is an opportunity for the Indian construction scenario and the construction players in the Indian market. Now we know that sustainable infrastructure, when you talk about, it's very imperative to understand that this is basically three guiding principles are to be satisfied when we talk about the sustainable infrastructure. One is the sustainable development goals, all of us know, and the disaster risk reduction Sendai framework, and as well as the United Nations framework for convention on climate change. So all these three things will lead to development of sustainable infrastructure. And when you talk about, again, India specific thing, as you know, our Prime Minister has given a clarion call for developing Atmanirbhar Bharat, and he himself has says that there are 5 pillars of becoming a self-reliant India, and infrastructure is one of them. So therefore, it gives us an opportunity to go ahead and be global player in this field. And how CSR SCRC can actually intervene, I'll just explain in the following slides. So these are some of the technologies that CSR SCRC have developed in the recent past, which are actually can be very useful for developing a sustainable infrastructure in India. I'll come to some of them I'll discuss in my following talk. Now, this is one of the very important success that we have achieved in the recent past, which is the emergency retrieval system, which are needed to restore the communication, power communication, immediately within 2 to 3 days after a disaster has collapsed, made transmission towers to collapse. So so far, these emergency retrieval systems or restoration systems, as they're called, ERS, they have been actually imported from outside. All the systems are imported. So this is the first time SCRC has come up with a design based on a lightweight modular system, which actually satisfies all the IEEE standards and can do the job of the emergency restoration. So this is an extremely good opportunity for Indian players to adopt this technology, which is also, by the way, can be also exported from India, because there is a huge market in the neighboring countries and worldwide for this. We have just transferred this technology to a Gujarat Ahmedabad firm, but it is open to be given to other also. Similarly, today when we talk about the COVID, we are actually going through a very difficult time, and it is also important that we sort of revive this trend, revive this economy to as fast as possible. And one of the things that is very important here is to come up with sort of hospital or isolation centers which can be done very fast, because even today we are talking about a second wave, which is going to come in the country. It very likely that there will be a second wave again. So therefore, there will be more and more people affected, and there will be need for having more and more isolation centers. So with that in view, SCRC has come up with this portable structure, which can be actually erected in no time, about half an hour, when you transport it to the site. And this transportation can be done. It can be completely folded, as you can see. And then when you go to the site, it can be fully installed like this in 30 minutes. And transportation can be done in a truck. So extremely useful technology, which we have actually transferred to L&T Mumbai, as well as we are talking to different other companies which will take up. And similarly, as you know that prefab construction is going to be the very important agent of change in future. That's extremely important because the constructions, particularly civil construction, is subject to the vagaries of nature, and it is only through the prefab adoption of prefab technology that we can have very strict quality control, like other other sectors, and we can also have a fast construction. So this is one thing that has been done in a campus, NDRF campus in Karakoram. We have actually, based on a prefab technology based on steel, we have made a 10-bed hospital, short-term temporary hospital for the COVID purpose there. So this is just a demo structure which was inaugurated by our Honorable Minister of Science and Technology as well as Health, Dr. Harshvardhan, recently. Now coming to the prefab technology, talking about more, SERC has been constantly working on it. We are aware of the limitations which are there, which sort of prevents the industry to adopt, but particularly the joint mechanism and so on and so forth. So we have been constantly working on it, and here you can see the first time in India a G+3 building is being tested fully in our tower testing research center. This is of course the shake-table test, but we also have tested a G+3 building in our tower testing research, full-scale testing. First time in India we have done. And there are many other things like EPS concrete technology, which is we are calling as Secro build, indigenously built EPS technology that we are extremely useful for lightweight prefab structures, which are also cost effective, which 25% advantage in terms of cost we have calculated, and we have developed and marketed to many companies, and it is open to to all others. And another emerging area is the textile reinforced concrete prototyping technology, where so basically it removes the possibility of corrosion altogether, because you don't use any kind of reinforcement which is steel. So here we are reinforcing with the textile fibers, and we can actually come up with very strong but thin sections, and for various purposes like industrial tiles, canal lining, toilets, crash barriers, and so on and so forth. It can be used for many purposes, and which I'm sure that industry will be finding it useful to use. This is just to say that we are also developing a very strategic thing like a hardened aircraft shelter, which can actually absorb the damage caused by 2,000-pound bomb attack. So that the design of this such a structure, which is a concrete structure of course, but it is a kind of a layered structure, are being designed by us in SERC. Now ferrocement is another thing which is has been there for some time, but still has not been adopted by the industry, particularly because it requires a highly skilled labor. We have recently tried to remove that barrier and sort of come up with a flowable ferrocement technology, so flowable concrete technology using ferrocement, and that is essentially we can make many things, including the water tanks you are seeing, the toilets, and many other places you can use with very thin sections. As you know, ferrocement we can use for these purposes. Now another thing that is very important today for sustainable structure development is the use of less cement, and so the zero Portland cement, which is a geopolymer concrete. Based on that, we have developed several technologies, you can see a school building which has been made out of this geopolymer concrete, which has been developed here, as well as the technology has been, several companies we have transferred this technology for making paver blocks, building blocks, etc. Now another import which is typically the threaded anchor bar, threaded end anchor, which is usually to remove the reinforcement overlaps, so that the congestion of reinforcement at the joints can be avoided. So these are typically again all imported. So we have developed a technology which can be used for Indian scenario, and this we are in talk to transfer this technology to various companies, including L&T. Now this is another very interesting idea of energy dissipating replaceable fuse link. So elements. So these are basically like electric fuse. Whenever there is a overloading in terms of electricity, you know that the particular fuse is disconnects the power, and it fails, and then it saves the component or equipments we are attached there. So similar in a way, if there is a disaster, high extreme loading, in that case we can design these joints in such a way that only the joints will fail, but the structure will joints will partially fail, where the structure after the extreme event is over will still be adequate to retain itself, so that the full collapse will not happen, and we can then replace the joint and bring the full capacity of the building after the disaster. So these are the replaceable fuse elements that we are working, can be very interesting for damage or disaster resilient structures. Futuristic technology, of course, is 3D printing. Today everybody is talking about, but we are not talking about. We are actually taking we have taken up an ambitious project based on the 3D printing, and we want to develop a learning space, that is a school building with 3D printing. So this will be the largest such experiment in India so far. A very ambitious project in collaboration with industry we are taking up, and as you know that it leads to a lot of benefit of construction waste reduction, labor cost reduction, as well as production time reduction, and particularly in the setup of rural areas, this can be actually a very good thing to do. It's almost a micro factory approach. So instead of doing a complete huge setup of a prefab factory, which requires a huge setup, in much smaller scale you can do a factory, and then you can develop buildings using the 3D printing. Now these are the sites that as engineers we don't want to see, because these are actually it tells that how vulnerable we engineers are, in terms of how that we feel helpless when such collapses take place. It is actually telling on our ability. So there must be something wrong that we are doing, that these things are happening. So therefore, there has been a talk all over the world that how do you prevent all those things, and eventually what has turned out come out as is called as the structural health monitoring of critical infrastructure. Now this is the diagram which shows that how you can sense structure and do the transport all the sensing data to your some head office through the IoT enabled cloud enabled system, and then do the analysis. And so you can network through the network you can actually connect n number of such critical structures and do analysis and try to see that which structure is going to be critical in near future and take appropriate action. So this is kind of a system that will be the that will actually prevent such catastrophic failure which happens. Of course, this is a very challenging thing, as this diagram shows that we are actually in many places. This is the Pamban Bridge, you can see. So we have done the structural health monitoring of bridges, but I tell you that this is not only installation of some sensors and just getting the data. The main question is that how do you interpret the data? What do you do with the enormous amount of data that that you store by measuring the response at some for long period of time. Now, so this is where the data science, the artificial intelligence, the machine learning, all those things come into picture, and we have shown in SERC through a very good team we have, and we have shown that how it is possible to make the data and then to predict that is some damage has happened in some place. So even we can even if you can predict that there is some damage, and by and large we can, if we say the locality where it is, we can always send people and then for the finer details to get it inspected, and it will definitely go a long way in preventing catastrophic failure. So this is another just glimpse of an effort that are underway in SERC in terms of the structural health monitoring. So these are structures which could be pipeline structure, these are called thin wall structure. So what we can do here is through sending guided waves, and which can be, by the way, can be generated very simply just by actuating some piezoelectric actuators, which are very small patches of actuators. So with that, it can be done, and then we can now interpret this data by different algorithms, and we have now come up with an algorithm which actually much better than the algorithm which is there in existing, and we have really shown that how our algorithm does very well in predicting the location of damage in these kind of structures using guided waves. This is again a new thing that we would like to do. We already have a plan. As I was telling, that a G+3 building, you can see, is being tested in TTRS, our Tower Testing and Research Center, for the first time in India, and this is important because the of prefab technology which are coming into the market. Now, how does it do in terms of the integrity of the structure? That is important to be tested. So that is why we are talking about this full scale testing, and we'd like to have a dedicated full scale testing facility which will be a national facility for such testing, and I welcome industry to make use of such facility and to spread the use of prefab technology in the country with confidence. And this is another thing that again I said that the futuristic thing that we must embark on, that is the high speed railway infrastructure. I think if industries are ready to take plunge into this, Indian industries will be very happy to partner and give the become a knowledge partner of industries, so that some of the things that are required to be done in the highway speed, high speed railway infrastructure, we can take up jointly, and many things can be done, and it's extremely important for the country to do that. So finally, I would just like to say that I would like to urge the Indian construction industries, the MSMEs and big industries, that please come forward and take the SERC technologies which are available not only in SERC. There are several other CSR laboratories which have technologies related to construction, and as well as we can also partner to develop globally competitive futuristic technology based on the requirement of the industry, Indian industry. So these are the futuristic and emerging things that I felt that the Indian industry should be adopting in the near future to become really globally competitive and to take charge of our destiny for our nation. Thank you very much. My details are there in email at the bottom, and if you want to write to me, if you have any questions, you are welcome to do so. Thank you once again. Jai Hind.
Construct Next is an approach of transforming by digitalization our industry or our projects by creating specific intelligent building systems using existing and emerging technologies. A quick bit about myself. I'm Sunil Prabhakaran, CEO at BAY, Building Architecture and Engineering, operating out of my Bangalore office, doing projects all over the country. Currently engaged in setting up a skilling academy called Next Academy, focused on the built environment and drawing deeply from the reserves of emerging and existing technologies in the process. Since we must all get consumed by this digital wave, we have put our domain minds to work, aggregated digital expertise from stalwarts around us to create a strategy, design, and implementation plan for measurable digital transformation in our industry by creating intelligent building systems, or IBS for short. We're inspired by Bryden Wood's inventive creation of a factory in a box, which could be shipped as an assembly kit to anywhere in the world. And by creating a step-by-step assembly process for such a system, the firm reduced the on-site team strength by 75% and the installation time by about 50%. So now what is Industry 4.0 as far as AEC is concerned? Fact of the matter is every company today has to think like a technology company, irrespective of the vertical it belongs to. We are no different. So the companies in the AC vertical will also be consumed by this 4.0 wave, and an intelligent building system driven by the technology disruptions is in order. So what is an intelligent building system, or IBS, and how do we use IBS to transform a particular industry of our choice or a live project? Digital can be either operational or strategic. Operational is when we make small changes in using digital technology to areas of rate analysis and quantity surveying or document management by having an ERP, etc. Or it can be digital, which is the intelligent building system, a product of strategic transformation initiative. And of course, with all things digital, even for IBS, data is king. For IBS to be created, we'll need to acquire, store, visualize, analyze, and process the data to create a rationale for engineering outputs that will be beneficial for the industry. With an IBS, we can help construction companies to save resources and increase productivity and improve project profitability and quality, reducing project duration and cost, lessening the complexity of project management, and enhancing site safety for promoting a sustainable development of the construction industry. To understand digital transformation and IBS, therefore, it's necessary for us to take a look at where we are at the value chain of the industry and how the digital transformation is going to completely disrupt each link of the value chain. Let's see. This slide shows a reasonably evolved value chain, which shows you each link from raw material to product manufacturing to design to construction, operations, maintenance, renovation, demolition, and back to raw materials. There are several stakeholders, actors as we call them. There are new actors or new stakeholders coming to the mix, and there are several types of innovation that are happening all around us in each of the industry verticals of the stakeholders. Now, when this happens, there is so much of data that are being developed. The intelligent building system is a result of compiling of all this data from all the stakeholders, processing it and using it, interoperability of the data that we're collecting to create the information and to process that data and to create a platform for mutual benefit, for everybody's benefit by collaboration. Let's see where we are headed. This illustration shows you where we are headed for in our quest for Construct Next. It's also an indication of the various technologies that are at play and how they can impact the various links in the value chain that we've seen earlier. There is prefabrication and modular construction, advanced building materials, 3D printing through additive manufacturing, autonomous construction, augmented and virtual reality, big data predictive analysis, wireless monitoring and connected equipment, cloud and real-time collaboration, 3D scanning and building information modeling, which will all contribute in no mean way to disrupt, create change in various aspects of the building industry, as you can see in the illustration. Every man, machine, resource, component, building system, equipment that you saw on the slide earlier is a thing as defined in the Internet of Things. So now that we have a brief introduction to what we are trying to achieve, let's create a conceptual framework for the IBS and design an implementation strategy for making it effective across companies and across verticals. Many of the big five consultants, such as the Boston Consulting Group, have embarked upon very ambitious strategic transformation initiatives using digital technology. We have drawn from companies such as McKinsey Global, Boston Consulting Group, etc. Used a very popular strategy implementation tool called as the balanced scorecard and used the balanced scorecard to create our own version of a value chain transformation scorecard to determine how companies can, in a step-by-step manner, by identifying key objectives and converting those key objectives to measurable outcomes and performance drivers, how companies can create a measurement scorecard for implementing a digital transformation strategy across their companies. As we said before, each link in the value chain undergoes a rampant digital disruption. We just look at the raw materials only because we don't have too much time, so we'll skip the other links in the value chain. So let's look at the raw materials, the basic building blocks, and how does digital disruption cause transformation in the raw materials and product manufacturing link of the value chain. So how is the raw material link going to look like in the near future? So this is the raw material and product manufacturing component of the value chain, which is said to be disrupted due to Industry 4.0, digitalization, and the various kinds of innovations from the various stakeholders. Time is not very far when you and I will go to a supplier and ask for 10 footings and 20 beams and 10 girders and so on and so forth. Time is not very far. We have today prefabricated RCC components, bath pods, factories in a box, all created by these new actors who want to basically shorten the time of the construction in societal interest and increase the profitability and the productivity of the industry. We have also converting this prefabricated components currently to smart construction objects, or SCOs as we'll call them in the rest of the presentation. Pre-built pods and construction systems, we are converting them to intelligent building systems and use technologies like additive manufacturing or 3D printing to create holistic solutions within a matter of days as opposed to years or months. The designers have to keep pace as well. The cement and sand and aggregate have transformed to bathroom pods and engineering building systems, etc., etc. So they've got to innovate and engage in the transformation through DFAMs, design for assembly and manufacture, and design for additive manufacturing. Similarly, with digital revolution impacting all the other links in the value chain, the combined value chain of the industry would begin to look something like this. Now, this is the value chain illustration where we are going to be pretty soon. Changes, disruptions, transformations across all the links: raw materials, product manufacturing, design, engineering, construction, operations, renovation, demolition, etc., through digital as well as non-digital disruptions. We have so far rationalized the need for adopting digital technologies to transform our industries, our companies, our projects. Let's now look at this process of creating an intelligent building system for prefabricated buildings in stages through the following slides. Let's look at the stakeholders and also look at how this presentation is going to be organized hereafter. First, a quick look at how the study is organized. First, we'll look at the technologies that are available to us. Then we create a conceptual framework of the intelligent building system. And then next we create an operating framework for the intelligent building system, and then thereafter an implementation framework. The implementation framework is across two different prongs. The first prong is a technology prong or a technical prong. The second one is a management prong, which enables you to outline the key objectives and draw the outcome and the performance driver measures to ensure that the companies take the transformation strategy seriously, and every department in the company, every person in the company is measured in terms of how they are performing with respect to contribution towards digital transformation. Here's a look at the stakeholders involved in a prefabrication setup, the tasks or the responsibilities that they discharge, and the main stages where they will be experiencing the impact of digital transformation through the execution of a particular project. So there are owners, authorities or regulators, designers, constructors, supervisors, engineers, component manufacturers, and logistics carriers. So with so many stakeholders and so many possibilities of systems and subsystems, what are the digital technologies available that are to be employed? In a prefabrication facility, prefabricated components are manufactured, such as footings and columns and beams, etc. Components are then assembled into construction systems. This is the assembly level. The earlier one was a unit level. And then the constructed systems are integrated into the construction sites, and this is called as the integration level. There are three levels in a prefabrication facility. Let's take a quick look at the different technologies that are involved at the different assembly levels. At the component level, we use IoT, RFID, and GPS to track and position the raw materials and components in the construction. At the system level, where the components are assembled into systems, we use IoT and a BIM platform to trace the manufacturing process and optimize the manufacturing schedule, analyzing the quality problems and arresting them. And at the construction site level, we have a concept of smart construction site by employing technologies of internet, 3D scanning, BIM, virtual reality, augmented reality, IoT, etc. And through a BIM based field management model that keeps talking with the BIM platforms of the manufacturers and the contractors subsystems to create a digital twin which has the same properties of the construction site. And so here is a summary of the different technologies very quickly. We have taken a look at the different assembly levels. We have also seen what are the technologies that can be employed across these assembly levels to gather the data. These data have to be grouped into blocks based on the source that they come from. A project level information data center has to be established, which is called as a PIC. An IoT BIM based database is established called IBDB. Authority monitoring and traceability system has to be established called AMTS, and an information system for products has to be established called ISP. These are the four different systems wherefrom we collect data, process that data by enabling interoperability and network flow, etc., and analyze and process the data to create information for the creation of the products through the ISP. So apart from the four systems that we have talked about, the creation of the intelligent building system also takes into account the various subsystems of the manufacturers, the suppliers, designers, contractors, etc. etc. So the collection of data, the analysis and the processing thereafter becomes an integrated whole. Without the collection of data and without the exchange of information over a network between the different stakeholders which determine the different sources of data itself, the possibility of creating an intelligent building system model will not be possible. And likewise, the ISP is a system for the construction of digital engineering products of prefabricated buildings based on all the integrated data and information which are processed and analyzed. Some of the subsystems which are employed by the contractors and the designers, the logistics operators, etc., are shown here. For example, project quality traceability system, which we call as PQTS, or the construction site resource element management system called REMS, component production planning scheduling subsystem called CPPS, etc. A few more of those subsystems: material supply management SCM of the logistics operators and the manufacturers, component transportation and dispatch system CTDS, and the integrated design system of the designers IDS, which subsumes the building information modeling system. In summary, therefore, the various systems that are employed along with the subsystems of the contractors, designers, and the logistics operators, etc., would look like this. We have PIC, IBDB, AMTS, and ISP, and a suite of subsystems which run across the manufacturers, suppliers, designers, etc., etc., compiling the big data that we need for the creation of the intelligent building solution. Now that we've seen all this, let's take a quick look at the conceptual framework of the IBS. Now here is how a conceptual framework of the IBS would look like. As you can see here, the various systems, AMTS, IBDB, ISP, PIC, etc., what we have seen earlier is depicted here, indicating very clearly the flow of data and information between the subsystems of the contractors, the authority regulators, and the owners. The various purposes why these systems are in place and the roles and responsibilities of each of the sets of stakeholders also loosely indicated here. The objectives of lean construction, maximizing benefits, supervising and control, safety and quality control, and quality traceability, etc., are very clearly indicated in this particular operating the conceptual framework of the IBS. The interaction between the project information center and the transmission of information back and forth across these different systems and subsystems through the networks of Wi-Fi, RFID, etc., and finally to benefit the construction site of resources, components, equipment, systems, men and things, etc., are also clearly indicated. So this gives you a basic or conceptual framework from which to develop an operating framework, and we'll see the operating framework in the next slides. Let's take a look at what happens in the IBS operating framework. We create a design model subjected to analysis and clash detection, etc. Once found compliant, a set of data is then transmitted to different frameworks, sub-frameworks. So a construction-oriented design data is transmitted for on-site construction. On-site construction data integration happens through the network of RFID, IoT, sensors, etc. A set of manufacturing-oriented design data is sent to component production data integration. Component production happens in real-time, data is uploaded back into the system, and if it is qualified, it goes to the site for on-site construction data integration. The data is analyzed, quality cleared. If no design conflict is found, the IBS is created and the project is finished. If there is a change that is required in the design as per a design conflict, that will be indicated. The loop goes back into the design model and the entire system reroutes itself as has been indicated in this. A lot of technology related interpretations are possible for such a framework, and it may not be within the purview of a typical architect or a civil engineer unless you are very, very technologically orientated to delve deeper into this, and therefore we have used a system of aggregation of domain experts, which we bring in the architecture and the civil engineering part of it, and the needs of the owners, which we bring in, and then we aggregate the expertise from technology stalwarts, and then create a platform called Next Lab to create solutions for the specific needs of our industry. The final step is creating the implementation framework. We look at the implementation aspect in two prongs, as mentioned earlier, the technology prong as well as the management prong. We recommend a simple 10-step plan to implement the IBS. First, you build the smart construction objects or the SCOs. Then you establish a data acquisition system, which we have seen earlier, the PIC, AMTS, etc. Collect data from the SEOs through the data acquisition system, which we have seen in the first part of creating of the conceptual framework. Establish network integration system, which we've seen in the operating framework. Connect the smart construction objects through the network integration system, which we again seen in the operating framework. Establish information integration system. Transmit collected data to the information integration system through the network integration system. We've seen the network diagrams through the operating framework. Establish data integration and analysis system. Establish a visual integration system, and establish a multi-layered application integration system, which is the final output of the implementation. The other aspect of IBS implementation is the management aspect, for which we create a value chain transformation scorecard. We've identified 10 different platforms for creating such a scorecard. Within each platform, we have key objectives, we have outcome measures, we have performance drivers, and we indicate the different technologies that are to be used and the different systems that have to be created in overall integration of creating such a value chain transformation scorecard. So the different platforms are prefab and modular construction platform, advanced materials platform, design digitalization platform, building information modeling platform, autonomous construction platform, big data platform, wireless monitoring, cloud and real-time collaboration platform, 3D scanning and photogrammetry platform, and blockchain platform. The establishment of a value chain transformation scorecard has been made possible due to the interaction between the domain and the digital experts at Next Lab. So we've created the framework for intelligent building system, identified the different assembly levels, the technologies that are to be used, created an operating framework, designed a technology implementation method, a 10-step method for delivering the intelligent building system for a prefabricated building, and finally this management control or management measurement of such a platform, how effective it can be or it will be, and how a company succeeds in implementing the strategy of digital transformation is developed through or is measured through a value chain transformation scorecard. Some of the examples of the scorecard are shown here. We haven't shown you the measures, etc., which will be done based on specific requests. As you can see here, this is a template of value chain transformation scorecard for a prefab and modular construction platform. The objective for this particular platform is clearly defined, which is production optimization, quality control, supply chain optimization, etc., etc. A brief description of what those objectives mean is also given in the other column, and there is a set of measures which are called as the outcome measures and performance drivers, which mention also the actual status versus what is achieved in current practice. The system of measurement, which we have not shown here, the different measures and the actual status, etc., will be specifically applicable to the companies that are employing this particular scorecard. Okay, the systems to be developed are also shown very clearly here. This we have seen earlier in the operating framework and the conceptual framework as well, and the technology suites that are employed for ensuring that the scorecard sits in sync with the technology implementation framework of the IBS is also shown in this particular template. So this is a template for the prefab and modular construction platform, whereas this is a template for a design digitalization platform. Remember, design digitalization does not end here. We have a separate platform for building information modeling, because it is building information modeling and Internet of Things that combine together to create the digital twin that is at the forefront of creating digital transformation in our industry. Similarly, this is a template for an autonomous construction and digitalized construction management platform. And this one is for big data and predictive analysis platform. And as we speak, we are getting ready with the digital transformation template for a prefabricated factory building of 2 lakh square feet, which illustrates the 10-step IBS framework and a 10-platform IBS strategy. As I've shown you, if you have queries regarding digitally upgrading your company, your project, developing a new system which automates construction, you can contact me on sp@baydesign.in, and I've given you the telephone number. It was a pleasure presenting to you from all of us at Next Lab, which is a concept from Bay Building Architecture Engineering. Thank you very much.
Up above the world so high and down on the grounds, the advancements that you see in India's aviation is the success saga of the excellence shown by Airports Authority of India. AAI is constructing, operating and
Good morning, good afternoon, good evening, wherever you are. And thank you for being part of this event. I am Ratan K. Singh. I am advocate and arbitrator. Good morning, good afternoon, good evening, wherever you are. And thank you for being part of this event. I am Ratan K. Singh. I am advocate and arbitrator. I am fellow of Chartered Institute of Arbitrators. I am fellow of Malaysian Institute of Arbitrators. I am fellow of alternate AIADR. I am fellow of FPD. I am senior fellow of Bali International Arbitration and Mediation Center. And I'm also fellow of International Academy of Construction Lawyers. I'm director of Chartered Institute
hosting us today. Really.
Hello, friends. This is Vivek Naik.
Hello, everybody. And today I'm going to talk about one of the scenarios of post COVID construction. And I'm going to bring this question to the forum: is 3D printing of concrete an option? Now, concrete 3D printing is a subject of much study all across the world. And in IIT, we have formed a team called Imprint, which is basically composed of IIT Madras, faculty and students of IIT Madras on one side, and also a startup company called Twasta Manufacturing Solutions, which is a specialist company that deals with manufacturing printers for 3D printing. Okay, so I'm very happy to bring this
Hi, I'm Daniel.
Hi, I'm Martin.
Hi, I'm Fernanda. Machine learning is pretty complex, so we've been experimenting with ways to visualize what's happening. There's a core concept in machine learning called high-dimensional space. Here's one way to wrap your head around this concept. You can think about people as being high-dimensional. For example, take famous scientists. You can think about when they were born, where they were born, their fields of study. Each of these is like a dimension of that person. These dimensions become difficult to untangle when you think about different people, because someone might be similar in some ways, but very different in others.
But this is the kind of thing you can use machine learning for. With machine learning, the computer isn't told the meaning of these dimensions, it just sees them as numbers. And it sees each set of numbers as a data point. But by looking across all of these dimensions at once, it's able to place related points closer together in high-dimensional space.
Here's a concrete example where words are treated as high-dimensional data points. The important thing to remember is that we haven't told the computer the meaning of words. Instead, we've shown it millions of sentences as examples of how words get used. Here's a visualization of the results. We're looking at a subset of words that the computer has learned about. Each dot represents one word. Each word is a data point with 200 dimensions. Using a technique called t-SNE, the computer clusters words together that it considers related, and clusters form based on meaning, even though we've never taught it the meaning of words. Here is a cluster of numbers, months of the year, words related to space, people's names, cities, and so on.
We can also look closely at smaller sets of words. If we search piano, we can run t-SNE only on words related to piano. We get clusters of composers, genres, musical instruments, and more.
And this approach doesn't just work for words. For example, you can also treat an image as a high-dimensional data point. Here's a data set where lots of people wrote digits between 0 and 9. People write in all kinds of ways. So the question is, instead of us needing to manually code rules for all the ways people write, could a machine figure it out itself using machine learning? Each image is 784 pixels. The computer treats each pixel as a dimension. Again, using t-SNE, it clusters these images in a high-dimensional space. We've color-coded them so that it's easier for us to see what's going on. And you can see groups of digits clustering together. It's learned something about the meaning of these digits.
These visualization techniques we've been exploring can be useful for all kinds of things. That's why we're working on open sourcing all of this as part of TensorFlow, so that anyone can use these tools to explore their data.
Today we'll be talking a little bit about enabling faster construction with modern construction chemicals. To tell you more about that, I'm here. I'm Sunny Surlakar. I'm a civil engineer and a concrete technologist by profession. I've been working a lot in the field of construction chemicals and just want to give you a window into who we are, what we do, and the kind of wonderful solutions that we can do to enable faster construction. So the agenda that we're going to be following today is we'll just briefly introduce our industry to you, talk to you a little bit about why we are relevant and what needs to be done, a little bit about the conditions that are today and what special kind of needs come out of the construction industry, and then pretty much what solutions, or that will be the bulk of what we talk about, is what solutions we can provide. And last but not least, we will conclude the session. So to give you an introduction to our industry, we are actually a very uniquely placed industry whereby we are a wing of specialty chemicals. So we basically take the knowledge from the chemical industry and we know how to apply it to the construction industry. That means what chemicals are compatible with, say for example, the traditional construction materials like be it stone, be it aggregates, be it sand, cement, and so on. So we work a lot on the compatibility and we find the right solutions to make construction much better. What we're looking to do is basically improve the durability and the sustainability of structures. Among our expertise is three basic, or rather we can split our industry into three basic expertise lines. The first one is concrete enhancement. That means we generate materials and we generate solutions on how to make concrete better in every possible way. How to improve its durability, how to improve its strength, how to improve its flow, whether we can make self-compacting concrete or we can make self-curing concrete, underwater concrete, waterproof concrete, and you name it. Like any kind of special properties that we need to impart to concrete can only be done by proper construction chemicals. Now, in case your concrete is not made or placed or cured in a proper way, it will show deterioration. And we also have solutions for that, which come through with concrete repair systems. So we can pretty much restore concrete back to its original condition or structures back to its original condition from whatever it is. And last but not least, once both these Welcome, ladies and gentlemen, to this session on construction chemicals as well as emerging technologies. Today we'll be talking a little bit about enabling faster construction with modern construction chemicals. To tell you more about that, I'm here. I'm Sunny Surlakar. I'm a civil engineer and a concrete technologist by profession. I've been working a lot in the field of construction chemicals and just want to give you a window into who we are, what we do, and the kind of wonderful solutions that we can do to enable faster construction. So the agenda that we're going